दो बाकी हाँ ठीक Ladies and gentlemen, esteemed delegates, dignitaries, distinguished guests, and colleagues, a very good afternoon. As we celebrate 175 glorious years of the Geological Survey of India, we now move into a session that explores the very foundation of Earth science, the powerful, hidden processes operating deep within our planet. On behalf of the Geological Survey of India, I, Kuljit Kaur, Senior Chemist, am honored to host our very first technical session, Geodynamic Riddles, the Depths of the Solid Earth. This session brings together cutting-edge studies on the Earth's interior, its tectonic, magmatism, crust-mantle interactions, and the deep time forces that shape the Indian subcontinent. Our presenters examine mantle-driven magmatism, the evolution of ophiolites, TTGenesis, and granitoids, as well as mantle metasomatism and crustal deformation across India, collectively offering new insights into how deep Earth processes continue to sculpt our geological landscape. To guide this session, we are honored to welcome our chair, Professor Naresh Chandrapant, former senior professor at the University of Delhi and an eminent geoscientist with over 4 decades of pioneering contribution to metamorphic petrology, polar geology, and evolution of the Indian cratons. We also extend a warm welcome to our co-chair, Sri Shiladitya Sengupta, DDD, PSS, PNM, GSI, a seasoned geoscientist whose impactful work in structural geology, mineral exploration, and environmental geochemistry has significantly advanced both crustal studies and environmental assessment in India. May I now invite Professor Naresh Chandrapant and Sri Shiladitya Sengupta to kindly join us on stage. Sir, please. Thank you, sir. Also, I would request Srimati Sonalika Joshi, Director, GSIWR, as our reporter, to come on the dais and record the proceedings of this session. Now, to open this session, it is my honor to welcome Professor Naresh Chandrapant, former senior professor at the University of Delhi and visiting honorary scientist at NGPOR, Goa. With over 4 decades of distinguished experience across ONGC, the Geological Survey of India, IIT Kharagpur, and IIT Bhubaneswar, Professor Pant has made pioneering contributions to metamorphic petrology, mineralogy, and polar geology. His extensive work includes more than 120 publications and 6 edited volumes, along with the landmark studies on high pressure metamorphism and supercontinent reconstruction in the Indian cratons. A recipient of National Mineral Award, he has guided numerous scholars, chaired the INSA National Committee on the SCAR, and continues to advance research on the sub-ice geology of East Antarctica and metamorphism in the North Delhi Fault Belt. Today, he will be sharing his insight on the North Delhi Fault Belt, reflections on metamorphism and mineralization. With great pleasure and respect, I invite Professor Naresh Chandrapant to kindly take the stage and proceed with his talk. Sir.
Shiladitya is a good friend. I hope he will be very lenient in looking at time. Okay, it is almost like a conspiracy when you have a talk scheduled after a very sumptuous lunch. But I hope that I keep you away from sleeping. That is the first goal. And then, of course, we can look at some of the interesting things. I have actually cut this down, this talk down to almost half of what I initially wanted to speak. Still, it is a little bigger than what I should have done. But there are specific ideas. I actually, and any time, please, anyone wants to interrupt in between when I am doing, you are welcome to do so. It will be very, very nice. So that will also show that my speaking is overpowering the lunch. So what I actually want to talk about is one or two simple things about North Delhi Fault Belt. The one idea which has been prevalent for a long time by eminent petrologists is that North Delhi Fault Belt, which is eastern Lal Sot Bayana Basin and Alwar Sub-Basin and Khetri Basin, has a metamorphic grade which increases from east to west. Now, because of paucity of time, I am not talking about Lal Sot Bayana Basin. If no presenter comes, then we will again go back and talk about that later on. But otherwise, we will look at the Alwar Sub-Basin and Khetri Basin and examine this in a modern context and see whether this holds good or not. And if you are not convinced at the end of the talk, I will apologize. But I believe I will convince you. Okay. So in doing this, we will also probably be able to reconstruct the pressure, temperature, time paths, assign some time constraints to these. And additionally, in last 6-7 minutes, I hope to talk about mineralization in Khetri belt and to talk about to link it or not link it to the metamorphism. So these are the aims which I want to accomplish today. We have talked about, we'll quickly look at this. We are only looking at the two sub-basins of North Delhi Fault Belt. We will also talk about the Delhi orogeny or this dilemma of separating North Delhi and South Delhi also. So when we look at the two sub-basins, that is the geological map of Khetri sub-basin from where mineralization is there on the right hand side, and on the left hand side is dominantly GSI generated map, GSI Faridabad from where I was earlier posted, generated map is there. The lithologies of Delhi's normally most of you know are basically the sediments, both clastic as well as calcareous, and some metavolcanic. So there are some lithologies which are suitable to decipher the metamorphic conditions. And remember, when we are going to look at the metamorphic condition of this in terms of increasing or decreasing rate of metamorphism, we are going to look at the peak metamorphic conditions. It will be very good if we can have more than one lithology, because then the data will have better support. It will be very good also if we can do it in terms of conventional method, in terms of what is called as reaction equilibrium modeling, as well as any other way by which we can support it. So these are the aims. So when we look at this, we will look at two pictures. So these pictures, as I said, this is only 20 minutes, so I will be quick, but please interrupt me if you feel that I am skipping or being too fast. So though of course in my present leg condition, being fast is not very easy. Huh? So when we look at the metapelitic rocks we are looking at, trying to look at two kinds of rocks. One is the shales and schists which are metamorphosed, metapelitic rocks, and the other basalts which have been metamorphosed to metabasic rocks. These are the two things which we are looking. When we look at the metapelitic rocks of the Alwar subbasin, which traditionally Lal et al., Lal and Shukla etc., say that it should have lower grade of metamorphism than the Khetri one, because it is east to west increasing. So, when we are looking at the typical metapelites of Alwar subbasin, we see garnets which show very distinct core and rim kind of differences. The cores are full of the inclusions and the rims are relatively inclusion free. We can actually characterize this whether this textural feature has chemical meaning, chemical context also. So, when you look at a map which this is, if you look at the scale, this is, you see, 10 millimeter. So, it is actually a thin section scale map. If you look at this map, you see colors. These colors represent the amount of iron or qualitative content of iron. The red or warm colors means more, and black or cooler color means less. So, you see that there are variations in different minerals. What are these minerals? If you look at the extreme right side where the scale is there, you see there is a sieve texture, riddled large kind of grain, that is staurolite, and all these smaller grains are garnets. If you remember, you saw garnets here which had two different textural domain. When we look at garnets, some of the garnets, let us say on the top right hand part, some are inside yellow and outside red, which means that higher iron outside, lower iron inside. So, this kind of behavior is there in some, and in some it is uniform, it is not colored. But you see all the grains which show two colors are inside staurolite. So, there is one big staurolite there are other staurolites, none in the matrix show two colors. Okay. So, when we look at, I am being little fast, please do not mind. So, when you look at this behavior now of one color and two colors, you see where two colors are there, and we are only plotting the almandine or iron garnet contact in this vertical scale. In this graph is almandine content, and horizontal distance is the size of the garnet grain. So, we see that where there are two colors, there is a gap of 10 mole %. Where there is a single color, the iron is increasing, but gradually. So, these two around 10 mole % is a significant amount. These two garnet cannot grow in one metamorphic event. In one metamorphic event, garnet can grow in a progressive manner, but not in a jumpy manner. So, therefore, this gives us an idea of two stages of garnet growth, which can be related to two metamorphic events in that area in the Alwar subbasin. So, again, as I said, we are not going into detail of how do we arrive at this, but we can use the inside inclusion, mica, biotite etc., and work out their pressure temperature by conventional means. The temperature difference between the inner garnet, which is iron poor, remember, and the outer garnet, which is iron rich, to be around, if you see, nearly 150 degrees centigrade. So, that sort of difference is there in between the growth. So, the composition is supported by the way they have grown. We will call this as M1 and M2 as two episodes as the Alwar subbasin rocks got metamorphosed, and we are talking about metapelites. Now, there is a technique which is known as reaction equilibrium modeling. So, in that what we do is not, I mean, name sounds or pseudo section. The name sounds complicated, but it is not complicated. what it is that if you can define a chemical system, which means how much amount of silica, alumina, etc., are present, if you can define that, and then you can use all the thermodynamic parameters, then you can model that at various pressure temperature windows what assemblages will develop. So, this is called as a pseudo section technique. It is a theoretical approach of developing phase diagram, but it is not theoretical in the sense that if you are able to actually estimate what chemistry is involved in developing these assemblage, you can actually work out a very good path to that assemblage. Now, minerals which are inside garnets etc., or earlier form garnet, they provide what were the earlier assemblages present. So, one can use that as one part or one point, and the overall growth as second point, and then this way can work out a PT path, pressure temperature path. And if you can add time to that, we call that as PT and time path. So, this is a pseudo section approach which we used to constrain the conditions which we had already estimated by conventional thermobarimetry. So, that yellow area which is marked, that indicates the conditions to be around, peak conditions to be around 700 of the assemblage which is actually present around 700 degree centigrade at a pressure of more than 7.5 kilobar. So, pseudo section is not very far from what conventional thermobarimetry was telling of the metapelites. Now, we look at the K3 subbasin. So, we will if K3 subbasin values are less than this, then we will say that it is not increasing in that direction, otherwise it is increasing in the reverse direction. Okay. So, before that we just look at some of the rocks which are present. Now, K3 is little bit complex in the sense that if any of you have been to K3 or read about K3 mineralization, it is actually there is lot of hydrothermal, there is lot of chloride developed. In fact, so much so that the rocks which are mineralized are also called as chloride schist. But actually those chloride schists contain garnet. This is a SEM photograph where the brighter picture means higher atomic number, darker picture means lower atomic number minerals. So, these are the garnets, and when we do I am again not describing all the rocks there. So, we are describing metapelites first. These metapelites, when we do conventional thermobarometry, we have this kind of results. Okay. We have this kind of, where you see that garnet chloride thermometer. You look at this, the temperatures are 561, 543, 572, 536, something like that. Distinctly different beyond the error ranges of these measurement, distinctly less than that for the Alvar subbasins. This is what is primarily indicated. Okay. We also do then in this case in the same way the second corroboration, that is the pseudo section approach or reaction equilibrium approach, and there also when we look at this, the peak conditions for K3 subbasin, which is on the left hand side, are around 570 degree centigrade at pressure of 7 kilobar, similar pressure, but the peak conditions for the Alvar subbasin are higher. So, the contention, long held contention that there is an increase from east to west is definitely not validated. Are there any other rocks, anything else which can support this? So, we look at amphibole bearing rocks, and you see they will provide some very interesting data. So, amphibole bearing rocks are amphibolites in the sense that there are some amphibolites there which contain calcic amphibole bearing rocks and and the others which contain without calcium, that is FeMg amphibole bearing rocks. Now, these two, fortunately these two rocks are also present both in the Alvar subbasin as well as the K3 subbasin. Those two black arrows show their presence in both of these subbasins. In the Alvar subbasins, these are in Bayal area, and in the K3 subbasin they are in the various mines, K3, Chandmari, Kolihan mines. Okay, so when we look at this, there is something very interesting. I would like at least youngsters to pay attention to this. What is that? If you have read about how, as you move from green schist facies to amphibolite facies, the amphibole composition changes. Amphibole initially, if you remember that triangular diagram ACF, in the green schist facies it is at CF line. If something on CF line, that means no alumina. As from green schist to amphibolite facies transition takes place, from CF line it moves to inside the triangle towards A, which means what? Aluminium gets increased. How does that happen? There are very complex substitutions possible. These are the list of substitution which are possible in amphibole to create this thing. So, if you look at, for example, the second adenite exchange. Adenite exchange is when there is initially in the actinolite there is no sodium. With increasing temperature, vibrations lead to higher size, ion size to be accommodated, some amount of sodium goes. So, in actinolite there is no sodium, in hornblende there is sodium and aluminum. Sodium and aluminum increase signify higher temperature. Now, if you look at this diagram now, there on the other side graph, that plots the, of course, most of the elements in terms of atom formula per unit. But what you see here, that when you look at these figures, the two encircled things, the one aluminum, you see there is a whisker plot which shows green color is that for Alvar amphiboles, and you see how much significantly higher aluminum that has got. Okay, you see this? This is for Alvar, this is for Kolihan, and the blue one is for Chandni. So these two are from the Khetri subbasin, and the other one is from the Alvar subbasin. Alvar subbasin aluminum is significantly higher, which means that it is a higher temperature amphibole. Similarly, if that reaction would have occurred, you look at the sodium, there also sodium is significantly higher than almost non-existent one in the Khetri subbasin, which tells us that our conventional thermobarometry as well as reaction modeling is very much supported by this data of minerals also, amphibolites also. So, two bulk compositions, various approaches, it is almost an impossible case now to defend that there is an increase. So, what we say very clearly, definitively, that actually it is the reaction in such a way that peak metamorphic temperature is there in the Alvar, and Khetri represents a lower temperature. How much time do I have? Okay, good. So, we can codify this now, these points which we worked out. The left hand side is Khetri subbasin, the right hand side is the Alvar subbasin, and we have marked these points depending upon the temperatures which we got and pressures which we got. So, you see that in Alvar subbasin we have got what is called as a prograde path. The prograde path is preserved in our data, because those data points with errors are marked there. Whereas in the Khetri subbasin, because it is significantly altered, we have only the retrograde part. We will combine these two together, and this is based on various combination of factors. It is very interesting data. Now, we will look at something else which we find few places in mines at stope faces in Khetri, and this is very interesting. What is that? You see that, believe me, it is absolutely, I had taken a batch of students to mine visit and we had collected some sample. This stemmed from that. So, it is such an interesting observation. You will see, I will convince you that it is important. So, what do you see is that you see biotite, which is written there. Then you see chloride. There is a lot of chloride present because there is a lot of retrogression in K3. Tremendous amount of hydrothermal activity is there. But what you see there, that at the margin of chloride, there is again a development of biotite. It can never happen till if there is no heating or heat supply subsequent to the formation of chloride. Now, this biotite actually compositionally is also differed from the big porphyroblastic biotite. So, which means what? That there was another heating event which caused the partially chloride to alter. You see that how it beautifully gets supported by, this is the textural this was a textural observation, remember only. When we did some good microscopy and also analyzed these grains, we found that there is a presence of a mineral which is called as cordierite. So, you see there with chloride, biotite, there is cordierite written there. Now, again, those of you who are better metamorphic petrologists than me would know that cordierite is present in those rocks which are very high grade rocks. But there are two stages where cordierite can be present, one in high grade low pressure rocks, and the other, it is typically marking of a contact metamorphism. Now, you can ask the question, how do we distinguish between the two? The cordierite which is present at very high granulite or metamorphic conditions occurs when potash feldspar has already formed, sillimanite has already formed. So, the assemblage will contain sillimanite, potash feldspar, and the assemblage will not include muscovite. Whereas, when we look at this situation here, a contact metamorphic cordierite, then it will always occur with chlorite and muscovite. This is the situation here, and it is very much in consonance with the marginal heating of chloride. This is what will happen in a contact metamorphic. And remember, this is from the stope phase, from where the rich ore of K3 was being mined. So, therefore, by circumstantial evidence, one can conclude that enrichment of copper or sulfide mineralization in K3 took place because of a contact metamorphic event. And this is a superposed event on the pre-existing assemblage. Therefore, if you look at the path there for chloride, it shows a here it shows a over imprint. It shows an over imprint of metamorphism, contact metamorphism. It is a second, not part of the same progressive metamorphism. So, this is very significant. I will tell you that how we were able to prove this further also. Now, this can be what I explained to you can be explained in terms of a common metamorphic reaction. There is empirical evidence of telling us what kind of temperature will be there. So, we can, I mean, this is a really very easy way of proving that this is a contact metamorphic event. The relationship of this contact metamorphic event with mineralization is even more interesting. So, we will talk about mineralization after we have concluded this part. As I said, we will take 5-6 minutes to summarize that also and see how normal petrographic work, normal geological work is very significant in mineral exploration. So, there are in K3 and Alwar subbasins, both subbasins have sulfide occurrences. In K3, there has been a mine running for 50 years, 55 years, and possibly it will run for another 50-60 years. Though I have a control on how to predict how much it will run, I will tell you how. And in the Alwar subbasin, there is a low grade, 0.4% is the low grade copper in the rocks present in the Alvar subbasin, and around 1 to 2% copper is present in the high grade Khetri which is being mined. So we will look at these two.
Sir, another 5 minutes, will it be okay, sir? Another 5 minutes?
Yes, yes, I just finished. Thank you. Friends are, you know, but it's a bad practice. I should not have done that if I have inconsidered.
Please, because it's we feel like a classroom listening from our professor.
So-
Wonderful.
So when we look at the same place from where I showed you those steps, this is the nature of sulfide mineralization. What is this? This is vein filling. It is a typical hydrothermal way in which the veins are filled. If you look at the SEM picture of that, you see a bright spot there. We were very fortunate to find this bright spot. This bright spot is monazite. And it is at the same time when the mineralization is crystallizing, forming. So therefore, it was a clue to date that. It allowed us to date that. When we look at the Khetri mineralization, so that is the face which is being mined not for copper but for road material. And there is a 10-15 meter wide shear zone in which there are calcite and quartz veins. You see there in the enhanced size of that rectangle is down below. Those places, pink places, because we are in pink city, so pink places show the calcite and quartz veins, and even larger manifestation of that you see calcite vein. Within that calcite veins occur shear controlled calcite and quartz veins, within that the low grade copper. Now when we look at the nature of minerals, the blue ones represents, the blue ones and the red ones represent two different mineral domains. That is, the blue ones represent minerals from Khetri, higher grade copper, and the red ones represent those from the Alvar subbasin. So there is a mineralogy difference also. There is some overlap, there is a distinct mineralogy difference. We can plot this on a phase diagram, whatever is available, of iron, sulfur, copper system, and in that we can distinguish, and it tells us that the Khetri mineralization, again I am not going in detail of that, is around 600 degrees centigrade, which was the temperature which we inferred for the contact metamorphism. Whereas the Alvar subbasin low grade mineralization conforms to 300 degrees centigrade diagram. You see those three diagrams are there, they represent different temperature domains. So that kind of correlation is there, which is very suggestive, that shear zone and related veins, etc. So two distinct domains here are very nice. Now we look at the geochronological controls for these two. When we look at the geochronological control, we used monazite at our Faridabad, GSI Faridabad lab dominantly. So the monazites were there in matrix in the metapelites which I explained to you earlier, where two stages of metamorphism which we had noted. There when we plotted the ages and tried to separate it in domains, you look at down below the table, 941 plus minus 23 at 2 sigma, 1099 plus minus 20, which means what? That around 950, 1100 to 950 represented the two ages, the low grade, lower iron containing garnet forming at around 950, and the higher Elmendine garnet forming at around 1100. The Delhi orogeny at least of 150 million year old, and not surprisingly, consistent with the textural data, much younger age for the monazite which was trapped. It was not only the nature, this number, but the nature of monazite. We published a paper in episodes on that, that these are going to be the characteristic of a contact zone monazite based on that. Okay. So this is dominantly the data, but the PTT path which we got, and if I again go back, and now I just take 1 or 2 minutes, I will not talk about the combined correlation. But I will ask you a question, that Delhi fold belt represents a Proterozoic or Neoproterozoic fold belt which has eroded to a certain level of structural core now. There is another Neoproterozoic aged or Proterozoic aged fold belt in eastern India, which is called as Eastern Ghat Mobile Belt, EGMB, that is also eroded to similar level. But there are very significant differences between the two. What are the significant differences? That it is only or largely made up of granulites, the Eastern Ghat Mobile Belt. Now these rocks are made where we are just touching, kyanite is there, at some places there is an incipient sillimanite. So there are significant differences. Why? They should be there. We reflected on that. If you look back at as I said, I will not take time, but if you look at this path, you look at this path of the Alwar sub-basin, what it shows? A trajectory where pressure increase is significant, the temperature increase is not much. So it is a high P, relatively low T type of path. And in convergent plate margins, typically this occurs in subduction zones, whereas in convergent plate boundaries, typically you have higher grade minerals present when it is a continent-continent collision. So we indicate that Delhi fold belt by this evidence is a subduction kind of margin, and actually it is proved. Can anyone tell me any pre-Delhi rocks present west of Delhi, Delhi fold belt, north or south? It is not there actually. There is no pre-Delhi rocks for hundreds of kilometers west of the Delhi fold belt, which means that represented an ocean basin only. Is younger than, yes. So therefore, you see how circumstantial it is. We are storytellers and we are building just simple petrographic evidence, etc. And if this is true, and if the contact metamorphism is the cause of the mineralization, till now in my knowledge, they have not encountered the body which led to that contact metamorphism. So the grade keeps on increasing as they are going down. This is also true. So therefore, this is a exploration guide. The day they will hit that, the deposit will not be there, but it is a guide at the moment in the western margin for any high grade rocks. If there is an effect of contact metamorphic, we see it will be there. Thank you.
Thank you, Professor Pant. Definitely, I think it was such a wonderful illustrative talk which we were mesmerized by your the presentation on simple understanding of petrography. He told us a story in his own words. It is a story which he developed just simple on certain simple studies of petrography and this thing. Sir, please come.
Okay.
So now it is
Any questions?
it is open to you, sir. You can even answer by sitting over here.
Sure.
So if you have any queries, please ask. Maximum two questions we can allow, because of the time constraints. Of course, we would love to listen from him. A longer period, but that is not possible right now. So if you have any queries, you can ask. Please.
Mic, please.
You can. I think if there is no mic, you can slightly be louder.
Sorry.
Yes, we have mic.
Yeah. Please.
Yes, I want you to read this also.
Sir, my question is,
Yes.
Go ahead,
in the
go ahead.
beginning of slide, you have presented garnet, where core is poor in iron, rim is rich. Sir, my question is, what is the source of iron that enrich the core, a rim?
Metaphylites contain iron.
Continue.
Metaphylites normally contain iron. Sorry, metaphylites normally contain iron. So it is the iron in that. So consider it as a shell, right? As the temperature increases, some mass within the shale starts moving. Some particles start moving. Shale is like, very uniform. But slowly what happens, alumina gets separated, forming white mica, initial white mica. So those layers become relatively alumina rich and rest becomes alumina poor. Similarly, some iron magnesium minerals start forming. So as a progress to that, it leads to garnet. So those places iron gets concentrated, rest of the rock becomes iron poor.
Thank you, sir.
In fact, with your permit, I will answer this a bit. So when we do effective bulk composition, I did not talk about that. That what is the, in pseudo-section analysis, we separate the garnet which is inside, because that part is not participating in the reaction, because within garnet the diffusion is very low. So we actually have published a paper on effective bulk composition in this way to show that how we can actually work out what is the chemistry or chemical system which is participating at different stages to work out very good equilibrium reaction modeling results.
I have a small query. You talked about those 2 stages of garnet development. I mean, could you also find microstructural evidences to, or was there any study on the microstructures, whether there are the phases of, or SiAC for that matter?
So actually there was, in terms of in staurolite also, in garnet also, staurolite has beautiful those structures, and they sort of sprout, they come out. So it is related to decompression there. Sure. We did some of that.
Thank you. Thank you. Sandeep, you please go ahead. Quickly, because of time again.
Very interesting and different insight, but just wonder, like, are there some minerals like tourmaline in that assemblage? Tourmaline or staurolite for that matter? Like,
There are very large staurolites. All those were large staurolites, but not tourmaline. There, no tourmaline pegmatites are there. These rocks are very good for effective bulk composition measurement, because these rocks are water saturated rocks where melting has not taken place. Melting has not taken place, so tourmaline etc. in with fluid environment will not form. So this is perfect in the sense when in high grade rocks melt takes place, they move away, the melts move away. So whenever, whatever amount of calculation you do, the effective bulk doesn't work out very nicely. But in these cases, they are perfect actually.
my line of thinking was, because this is the first time I'm hearing this, and my line of thinking was that similar type of situation was arising in is present in Sakoli fold belt. But there's a paper last year, I think we published a paper wherein it was thought to be of a higher grade metamorphism, but ultimately it turned out to be a metasomatic.
No. So this is not a metasomatic case. No, there is no evidence of this.
So that means the chloride, the biotite which is forming as a contact metamorphism, or the chloride for that matter, is rampant throughout and not confined to some alteration zone.
Contact metamorphism is always relatively localized. We were fortunate to get that. So it will be at few places only.
Okay, so thank
It
you.
is a metapelite. Chlorides, say again, it leads to formation of biotite.
Thank you, sir.
Thank you, Pant sir. We sincerely appreciate you for sharing your valuable research and perspectives with us. And we now hand over the proceedings to our start with the technical.
That is okay, walking? So please start, Mr. Sridhar.
So our first presentation. Uh,
Mr. A.N. Sridhar, please come. The next speaker would be, let me also tell in the beginning itself, Sujang Khiamniamgan. Are you there? Sujam? Okay. Be ready, huh? Mr. Sridhar, you please start.
Yes.
10 minutes and then 5 minutes for any queries or questions. Okay?
Thank
Keep
you.
it within
Thank you
10
very much. And good afternoon, everyone. Myself is N. Sridhar, and I am coming from the Kakatiya University. First of all, I would like to thank GSI for accepting my abstract for the oral presentation. And this was a oral presentation is details about an mafic intrusion of present within the Karimnagar granulate belt, where it shows some peculiar petrographic features and as well as some geochemical characteristics. So I am going to present in that. So this is a presentation overview that has enlisted topics here: introduction, geological aspects of that study area, field petrography and mineral chemistry studies, geochemistry, geochronology, and followed by conclusions. As all of us know that mafic dikes are considered as the barcodes which are mainly helpful in reconstructing the paleotectonic conditions and as well as constraining the magma plumbing systems, because as they are the frozen conduits, so it can preserve many kind of magma means magmatic recharge features and as well as the other kind of temperature and pressure variations. So, and it can also be used as for the reconstruction of the tectonical. So can I show here? I am using a laser pointer here to show you how. So it is a highlight pen. Yeah. So here we can use it for the reconstruction from by establishing their geochronological and paleomagnetical results. Then this is the geological area of the investigated area that forms a part of your Karimnagar granulate belt, that is the northeast extreme of your eastern Dharwad craton, where that the geological domain that I have investigated this dike consisting of multiple kinds of high grade metamorphic rocks like chornokites and enderbites and granulitic type of rocks, in which we found some a kilometer length of a dike, mafic dike. So this is a Google image that's showing the extension of the dike, where I also showed here the outcrop patterns of that dike. That dike is showing the outcrop patterns are not much appreciable, although that the contact between the country rock and the dike has established through a well section here, and this is the physical sample, and it is the microscopic thin section level, and these are the micro photographs where that this rock has characterized by high Mg mineralogy like high forstritic olivine, and then it is followed by some orthopyroxene, predominant orthopyroxene, and it is followed by some CPX, and along with that all of the silicate phases consisting are embedded with the chromite. That is a very much interesting feature of this dike. And apart from that, we have also noticed some kind of different textures. One type of texture that is that present there in the plutonic conditions and at the shallow condition level, that quenching of the coexistence of your phenocrustic and as well as the quench textures, and this ignited the interest to taken up further this work for the geochemistry and all, to understand how magma, whether that any magmatic recharge has happened within the existing rock. So this has been proven by some observation of resorption textures or dissolution features, where this can see here the euhedral halving has participated with the remaining melt, and that remaining melt has digested that I could say that is a magmatic cannibalism, where that melt intrudes it, digested the earlier crystals and intruded the remaining melt into those portions. So all of these textural features evidences that there is some mineral melt interaction between existed within this dike. And coming to the part of mineral chemistry, we did all of the silicate phases along with the opaque phases. That interestingly, that this is not characteristic for a mafic rock to contain any means a subalkaline rock to contain any K feldspar, but incidentally we have found some K feldspar within the mesostasis, and the plagioclase composition corresponds to your oligoclase and andesine, and then the chromite corresponds to chromite and aluminum chromite, and here a few or finite compositions of phlogophytes have also been identified within this, and we have performed some equilibrium tests to see whether they have equilibrium crystallization is there or not. So, but surprisingly we found some anticrysts of olivines and as well as some fractionated olivines, both populations present in the same sample, and the orthopyroxenes of two generations, one is of coronal and as well as one is of magmatic, both show some chemical differentiation. And CPX is also we have analyzed both the phenocrystic and as well as the variolytic or quenched crystallization, that we found some variolytic difference in the variolytic composition of CPX. So those corresponding compositions have been plotted within the chemical classification diagram of your pyroxenes, and the composition of the pyroxene corresponds to augite mostly, and the orthopyroxene corresponds to your enstatitic end member. And comes to the geochemistry, these rocks are enriched with high MgO, chromium and nickel, and their composition is equated to the mantle rocks. And classification, the conventional classification diagrams have shown that they are consisting of high alkalis. This is, I will explain this because of some reason that the alkalis have escalated within this rock, and these have been because of the high MgO. These rocks have been classified as the picrites, and you can see here the geochemical trace elemental patterns here. These are showing the enrichment in the LIE over HRE, and here this part of the trace elements which are depleted within the niobium and tantalum, and but the enrichment is observed for zirconium and hafnium, which is not which is usually anticipated for the rocks which are which have got contaminated by the continental crust. So although it is the representation of the contribution of the continental crust, but we cannot rule out the possibility of subduction enrichment also within the generation of these rocks. And coming to the AFC modeling to see whether any upper continental crust involvement is there, that all of the samples are confined to the end of means that totally resembles the continental crust, but it is unlikely for this. So, but we need to further explore possibility of how much percentage of continental crust that has involved in these genesis of these mafic rocks. So, although all of the conventional diagrams are suggesting for the AFC, but we need to have some more ancillary data to prove the continental crust has totally involved. And here also the PS diagrams have showing that there is an interaction between the plume lithosphere. There must be some plume impingement that melted the subduction modified melt, and upon which these dikes have been intruded into the post subduction rifting environment. And coming to the geochronology, we did some geochronology on the high Mg rocks that we could found some zircons, but here also the zircon geochronology is suggesting that there are multiple populations or heterochronous zircons are present there. This might indicates that several populations of crustal material have been involved within the genesis of these rocks, but based on here we have different populations ranging from 2.7 to 1.9, but comparatively these dikes are correlated with the Karimnagar Bangalore dike swarm because of its trend is also matching with them, and the ages are supposed to match with them. Only one zircon we got at the core as 2.2 and rim by 1.9, and rest of the zircon grains geochronology is suggesting they are matching with the host rock. So we confirm that there is some involvement of the host rock into the dike magma during their emplacement. And if you see closely look the geochronology, the rare earth elements elemental concentration of the zircon, they are showing two generations. One is from hydrothermal and
Minute, okay?
yes sir, I will finish it. So most of the zircons, analyzed zircons, are showing the unaltered magmatic signatures, and their classification in these diagrams, according to these diagrams, are mostly derived from the subduction related environment. So based on the high MgO, that we classified these rocks as the picrites only by using the chemical criteria, but we need to get more into the magma chamber processes like recharging of magma and involvement of the crustal or incorporation of the crustal materials into that. So we need to have more close space sampling of these, and along with the host rocks and another rock of the older ages. So if we date them, and as well as if we get the isotopic signatures of those host rocks and the studied rock, then we can constrain a good petrogenetic model for this studied dike. Thank you very much. So although I am very fast because of the time constraint.
Yeah, thank you, Mr. Sridhar. Now, if anyone is having any questions or queries, yeah, please.
Sorry, sir.
What is the distribution pattern of the K feldspar you have reported in
It
your
is
rock?
present within the mesostresses. We could not identify any phenocrystic phase.
Okay.
But VPMA has confirmed that there is some.
Is it coexisting with the quartz lamellae?
No, sir. No quartz
Not
is
at
there.
all?
No quartz is there.
Sridhar, it is not a question, just suggestion only.
Yes, sir.
So what we are studying in Karimnagar gland, it is covered by the aeromagnetic data by GSI,
Yes, sir.
block 6.
Okay.
Okay, sir, it is available in NGDR. We can correlate with geochronology with the aeromagnetic dike swarms.
Oh, okay.
What is the pattern? Clearly marked dike pattern in that area
Okay,
by
sir.
using aeromagnetic data.
Okay.
Thank you.
Thank you, sir. Thank you very much.
Anyone? Or else, once you have.
Just Sridhar, one observation. You have olivine, orthopyroxene bearing dikes.
Yes.
In the plagioclase is the oligoclase andesine. Does it not suggest that this is a secondary plagioclase, altered plagioclase?
Yes, sir. There might be some process of sassurization or some alteration.
No, not. It is definitely. You will with that you cannot have such high sodium plagioclase.
Okay.
It's very, very peculiar actually. That needs to be seen. So the one possibility is that it transforms very quickly. In mafic rocks, the plagioclase composition, losing calcium is a very quick process with a slight amount of water and other things it happens.
Yes.
So then you cannot use that. Those samples need to be considered as altered for that reason. Okay. So you have to be careful. You also have to be a little bit careful about zircon data. Also. We'll not discuss in detail, but I mean cannot consider zircon just because their populations are different, then you are considering them as external. And then one which is matching with the age, it is not a good enough reason. I mean, it is only a statistical reason that this is
Yes.
there. So either zircon are there or they have been an external element. One of the two things have to be considered.
Yes, sir. And we considered here that because these rocks are showing some contamination signatures. So for that reason, we have correlated with that incorporation of multiple
But then they cannot be used
Yeah.
to date the
rock. Yes,
That is-
yes,
that is the point.
yes.
If there is contamination, then
Yeah,
this
definitely
entire
we will have
geochemistry
multiple
becomes,
populations of
topsy-turvy, yes.
So we are in the process of extracting the bedellite. Then
The same
we
thing as said, that you cannot then use that as a geochemical discriminant diagrams which you have used, because if it is contaminated, it is contaminated.
So we are exploring further
Have
techniques.
your cake and eat it. That is what you are trying to say.
Okay.
That care has to be.
Yes. Thank you, sir.
Anyway, thank you. At least a good attempt. Good attempt. So let us go to the next speaker,
Sujan.
Suja. Please come forward. Sujang, again, please keep yourself restricted within 10 minutes of presentation. Okay.
Are all presentations loaded or some are missing?
So, out of this one,
Anyone here who has not loaded his or her presentation?
then you can just share it with them by the time they can load it. If anyone is having any presentation. Everybody has come, I hope. These 5 presenters, 1, 2.
Two are missing, so two should be.
Then what about Suranjan Ghosh? Are you there? Petrogenesis and temporal evolution of Paleoarchean to TTG. Are you there? Okay, I think he is missing. Then Bhaskar Jyoti is there, I have seen. And Akanksha, are you there? Akanksha Joshi? Two are not there. So I think you can, the stage is yours. Yes, go ahead.
Good evening, everyone. I'm Sujang Khamnyungan, a PhD scholar from Indira Gandhi National Open University, New Delhi. Today, I'll be presenting on petrogenesis and tectonic magmatic evolution of the Naga Hills of Phyllite, Northeast India, insights into the complex tectonic setting and magma depletion, co-authored by Dr. Gogoli Gogoi, Associate Professor from IGNOU New Delhi, and Dr. Kevilo Totenyo, Senior Geologist, GSI Jaipur. The Phanerozoic ophiolite in India are primarily located in the northern and eastern Himalaya region. Tethyan ophiolite distribution placed the study within the context of the Himalayan orogenic system, noting the Naga Hills ophiolite location along the eastern margin. The northeast-southwest trending ophiolite in the northeastern state of India occur in the hilly ranges of Nagaland and Manipur. We have the idealized ophiolite sequence, which shows the standard vertical layering of the oceanic lithosphere. From bottom to top, we have the perithotites, we have the mafics, then we have the pelagic sediments. The Naga Hill ophiolites, they occur as a narrow belt approximately 200 kilometers in length in the states of Nagaland and Manipur. About 90 kilometers of that belt, they fall within the eastern part of the Nagaland state. The Naga Hills ophiolite comprises of the serpentinized peritotite, mafic volcanic rocks, chert, limestone, metabasalt, and highly serpentinized ultramafic rock as serpentinite. Most rock outcrops are highly altered due to extensive deformation and thrusting, often covered with thick soil and vegetation. The northernmost part of the Naga Hill ophiolite is located in Nagaland state in the northeastern region of India. The geological map shows the distribution of formations and rock type marked by structural features such as your fault and truss. The ophiolite is overtrusted by the metamorphic rock in the eastern side and overlies by Desang in the western side. The petrographic studies characterize the type of rocks from the study area, which we'll be talking in the coming slides. As we see that dunite usually appears as highly serpentinized rock due to extensive serpentinization of the olivine mineral. However, in our study area, we observe well-preserved fresh olivine crystals, as you see in the below. We have the chrome spinels. In the serpentinized olivine, we have a smaller size surrounded by magnetite rim, whereas in the fresh dunite, the chrome spinels are in larger grain size. We also observe hespergite and lazulite. As you can see that the hespergite composed of orthopyroxene and a very minor amount of olivine. Here also we see chrome spinels as well. In the lazulite, they contain both the clinopyroxene and orthopyroxene in addition to minor olivine minerals. The orthopyroxene here in the slide, you see that they are present as anhedral grain with mainly corroded boundaries, which indicate the melt rock interaction. And the olivine, they appear as small, less altered crystals inclusion along the corroded boundaries of the orthopyroxene, which are neoplastic in nature. And you will see that the chrome spinels or chromium spinels in the lazulite are in anhedral in shape, comparing to these dunite and hespergite, which are more euhedral to subhedral in shape. We also see, we also identify serpentinite rocks, which are resulting from the alteration of the previously discussed lazulite and the hespergite rock. And there is also clinopyroxenite rocks. The clinopyroxene minerals that exhibit thin orthopyroxene exsolution spinels. And the chrome spinels that you see in the clinopyroxene, they occur as small discrete inclusion comparatively to the dunite, hespergite, lazulite, which are larger in size. We also observe the chromatite rocks, which are predominantly consist of the chromium spinels. A key feature of the chromatite rocks is the chromium spinels is the extensive fracturing that you will see. There's also basalt rocks in the mafic section of the ophiolite, where we'll see the plagioclase laths, and then as well as pyroxene minerals of both orthopyroxene and clinopyroxene. From the geochemical studies, the AFM plot, we'll see that the peritotite rocks, they are clustered in the field of metamorphic peritotites, and the chromatite rocks, they fall within the ultramafic cumulates. From the bivariant plots of orthopyroxene, clinopyroxene, and olivine, the data points they are plotted across two main fields, which is your forak peritotite and abyssal peritotite. As you see here, in the orthopyroxene field, we have the lazulites are plotted within the abyssal peritotite, whereas your hespergite, dunite, and clinopyroxene are plotted in the forak peritotite. Similarly, in the olivine plot, samples they plot along the olivine mantle array, validating them as residual mantle olivine, and confirms the dual affinity of both the abyssal peritotite and the forak peritotite. Coming to the clinopyroxene bivariant plot, They also reinforces that the lergerite have the abyssal signature, while the dunite and hesbergite they lean towards the four-arc environment. The spinel tertiary plot. This plot classified the tectonic setting based on the composition of the chromium spinels. Most data points within the super subduction zone field, and only a few of the lergerite they fall towards the abyssal peritotite fields. This spinel indicates as well the dual affinity with a dominant of the suprasubduction zone setting, but retaining a relics of its initial mid-oceanic ridge origin. Coming to the chromium versus DiO2, chromium number versus DiO2 plot, this plot shows the degree of melting and reaction with the arc-related melts and mid-oceanic ridge basalt. The chromite, dunite, and hesperkite, they clustered near the high chromium number, suggesting high percentage of melting, which are greater than 20%. And whereas the lergerite near the lower chromium numbers suggest lower percentage of melting between 5 to 10%. Coming to the titanium oxide and aluminum oxide bivariant plot, the chromatite, dunite, hesperkite, they are plots in the suprasubduction zone field, whereas the lergerite plot near the boundary within the mid-oceanic ridge type peritotite field. So this reinforces the interpretation of the dual affinity that we have been talking about with an overriding suprasubduction zone characters. We have the trace element and rare earth elements. The shapes of the curves, that is the trace element analysis of dunite, lergerite, hesbergite indicate a highly depleted mantle source, which have been influenced by the subduction related environment characterized by your positive lead anomaly over here. And then we also have the rare earth patterns, which shows characteristic of your strong depletion. Except for your clinopyroxene, they show enrichment. So the conclusion is that we have dual tectonic affinity. The Naga Hills ophiolite records a complex multi-stage history. The geochemical data from peritotite and spinels, they reveal a clear dual affinity, not a single simple setting. The mid-oceanic ridge basalt signature, the lergerite consists consistently, they are plot in the abyssal peritotite field. This suggests an initial formation of a Tethyan mid-oceanic ridge spreading center. The dominant supersubduction zone setting, the majority of the samples, that is your dunite, hesperkite, and chromatites, they show a clear and dominant supersubduction zone. Highly depleted mantle, we have the spinel chemistry confirms the supersubduction magmas were derived from a highly depleted mantle source that underwent high degree of partial melting. Tectonic setting, we have the Naga Hills ophiolite likely originated as Tethyan oceanic crust that was subsequently trapped and heavily modified by subduction-related magmatism in a four-arc setting during the closure of the ocean. Thank you. I'm open to suggestions and observations to improve my research.
Thank you, Sujan. I think again, if you have any queries, or I'd hand it over to Pansab to give some suggestions. She's a young researcher, I suppose. If you have anything.
Are there any questions? No question? Okay, Susan. Sujan,
Yes, sir.
you are not very convinced with one photomicrograph. If you go back just to the orthopyroxene did not look like orthopyroxenes to us. Can you, yes, this one, the central one. And the rock also doesn't look like a pyroxenite, Harzbergite you said.
Sir, I have confirmed it through the EPMA data as well.
Birefringence. Yes.
Yes, sir.
This birefringence will probably not match with that. The relief, of course, can be, I mean, relief does look low, but then we don't have a PPL photo. Please check that again.
Okay, sir.
That is important. As you said that you have two chemical signatures basically. One which is representing abyssal peridotite, and the other one which is representing forearc. Supra-subduction zone, you are saying.
Yes, sir.
So what is the difference between supra-subduction zone and forearc actually? This is not very clear to me. One you are talking about supra-subduction zone and
Sir, I was talking about this abyssal
no, one
peridotite.
is a convergent context. Yes. Do you get the point?
Go to your first, last slide. Conclusion slide.
Supra-subduction zone, oblique forearc peridotite fields.
Sir, I was trying to show that the samples, the once the plot the falls in the bivariant diagram, they fall in the forearc peridotite fields, but then they are regarding through the whole of the chemistry, we say that they are falling within the supra-subduction zone.
All the plots are essentially because of aluminium. You agree, na? Basically aluminium which is leading to abyssal peridotite or not. All your plots. Do you agree or not?
Yes.
Huh? You can see in your plots actually. It is only the difference in aluminium content. So these aluminium contents are that of mineral or rocks?
Sir, the bivariants I did from the mineral chemistry from the EPMA. Yes, sir.
So don't know. Are you sure that they are mineral, or you have plotted mineral data?
Yes, sir. I took the data from the EPMA.
No, you must have taken data. In peridotite, what are the minerals?
So in peridotite, we are getting the lazulite and hespergite. There we have the orthopyroxene, clinopyroxene, and olivine also, but the percentage they
So
vary.
none of these contain aluminium. Likely, I mean, very small amount of aluminium. Orthopyroxene, clinopyroxene, olivine do not contain aluminium. That is why I said possibly if you look at the plot, just see, go back. I just take care of these things. I am not questioning you.
Yes, sir.
Al2O3 weight percent. Hai na? And what you have written there is rock name. Dunite, lazulite, harzbergite, kleinwald. So these are rock names, not mineral names.
Okay, sir.
I don't know. I mean, you should be clear that what you plot.
No, sir. This plots I was trying to show. This is fully of the orthopyroxene minerals. This one, the whole plot, and this one is for the olivine minerals, and this is for the clinopyroxene. These samples, the ones that are plotted, are of those orthopyroxene of those particular rocks I was showing.
Okay, okay, that's all right. Thank you.
Thank you, sir.
Thank you, Sujit. So I think since we have only one left, please come forward. Bhaskar Jyoti. Yes, yes. I think Akanksha Joshi is from GSI. Am I correct? Huh? Okay.
Thank you. Yeah. Thank you. Thank you very much. So, good afternoon to everyone. I am Bhaskar Jyoti Gogoi, a senior geologist in the Geological Survey of India Training Institute, Hyderabad. So this work is from the Shillong Plateau. So this was an outcome of a petrological item which we did for 2 years. So basically this item is about a dike swamps containing lamprophire, tinguites and dolerite that occurred in the western part of the Shillong Plateau in the Garo Hills area, particularly in the Rongjen area. So earlier these were reported in 1980s by Nambiar et al. And later subsequent works have been done. But there was not a comprehensive work on all the dikes. A few limited 1 or 2 dikes were there. Nambiar sir, he has given an initial petrography and geochemistry of a few dikes, though he has reported in his map of more than 100 dikes. And later subsequently from some universities and some correlation work was done, but there was limited to 1 or 2 dikes. But here we took up this item to get a comprehensive approach on all the 3 types of dikes that are found in that area: lamprophire, tinguite and dolerite. So our study area was this in the red box that you can see. And this is an enlarged 1:50,000 scale geological map of the area. This area consists of is part of Assam Meghalaya gneissic complex. Those are quartz eliminaceous, some BMQ, amphibolite, biotite gneiss is there mostly, granitoids of the Cambrian age. Then we have this Wagasi Rongjen Nongcheram dike swamp, which consists of some unclassified mafic dikes, lamprophire, tinguite and dolerite, and above them we have sandstone and siltstone of the Jaintia group and alluvium. So in this work we have identified 34 dikes. 17 were lamprophire, 9 were tinguites and 8 were dolerites. These dikes mostly have a north-northwest to south-southeast to north-northeast to south-southwest strike, sharp contact with the granitoids and the Assam Meghalaya gneissic complex. This is mostly with the gneisses, biotite gneiss or quartzophosphatic gneiss. In 2024, from the first year what we have worked on, we have identified 9 dikes which we have published on the petrography, geochemistry and the mineral chemistry of these dikes. So these are the sample numbers and the location on the map. And here are the few field photographs of the dikes. So in the first photograph you can see there is a sharp contact here of this lamprophire with the gneissic host. Here also one more dike is here. And closer photograph we can see the penidiomorphic porphyritic texture of the dike. These are some amphibole phenocrysts with some biotite in the lamprophire dikes. Here we can see a large crystal xenolith. Actually it is a granite of the host rock which is embedded within the dike. Here also a photograph of the dike cutting across the rocks, and we can see the dimension of the dikes at some places up to 20 meters width. This is a tinguite dike, and a fresh broken surface of the tinguite dike looks like this, grayish in color. In contrast, the lamprophires are darker and the dolerite are much darker. And these are a few field photographs of the dolerite dikes. Now coming to the petrography of the dikes, this calcite are in one sample of this lamprophire in the Rongbo area. This is typically found in those dikes only. We have some clusters or xenoliths of aggregates of pyroxenes and biotite within the dikes. In few dikes we have this reverse zoning is observed in the phlogopite biotites. Mainly 3 types of phenocrysts are found in these dikes. One is phlogopite, biotite, pyroxene and amphibole. So based upon the petrography, these lamprophire dikes can be classified into 2 groups. One is biotite dominant and one is pyroxene or amphibole dominant. So in all these phenocrysts we can see effects of zoning. In these slides you can see, in all these slides. And these slides from G are slides of the tinguite. In tinguite we can see these pyroxenes are there, the greenish color, and some xenocrysts are there which are showing some disequilibrium texture. Surrounding this corroded biotite and amphibole phenocryst, we can see small microliths of pyroxenes, very small. We'll come to that. And enhanced images looks like this. Here also we can see in a small pyroxene also color variation is there, some zoning is there. In coming to the BSc images of this tinguite, we can see that this darker rim what we have seen over here in some sample is actually azurine. and this phenocryst of diapside. So this azurine does not only becomes as an overgrowth on the phenocryst, but also occurs in the microliths in the ground mass, and sometimes it forms clusters, dark clusters it forms. So here also one more photograph of the corroded texture. We can see biotite is being consumed over here, and microliths of azurine is forming over here. So this is an enlarged image of this, and in a few samples we found nepheline also. Some pseudomorphs are there. Here is one more feature, and these two photomicrographs are from the dolerite or the basalt samples. Some places it is a very coarse grained, so we can say dolerite, and in few samples, in few dikes, we have found this glass also here. So coming to the mineral chemistry part of the dikes. So first two diagrams represents the pyroxene chemistry. So the pyroxenes, mostly in the pyroxene dominated ones, they normally show the normal zoning in the rocks. But in the tingoid samples, they show the reverse zoning. And also in a few dikes, like in 4LC, 4LD2, this reverse zoning pattern was seen, as we can see in this sample, in this image, where we have plotted these MGO values, MG number values. And also oscillatory zoning we can see in a few dikes. In this plot, in the L versus SI, we can see there is a negative trend. So this trend is normally linked with the alkaline dikes type of rocks. Here also we can see, plotting the pyroxene data, the pyroxene shows a distribution from high pressure to low pressure pyroxene. So we can say that within the same dikes, there was different level of emplacement or the crystallization of the dikes. Here in this sample, we can see that the pyroxene data mostly corroborate with the alkaline lamprophile type rather than a calcaline lamprophile type. In this diagram or plot, we can see that these dikes mainly conform with the anorogenic type, and this is one of the BSc images as we discussed earlier. In this biotite plot, we can see that the biotite rich variant of the lamprophile, the composition of biotite is mostly phlogopetic. And in the pyroxene rich variety of the lamprophile, the composition of the biotite ranges from phlogopite to aninite. So we can see the strong dependence of differentiation or fractionation in this pyroxene rich variant. Here is the photograph of the zoned biotite that we have shown in the earlier slide. We can see that here is a reverse zoning pattern. At core, the Mg number is very less, and at the rim, the Mg number is high. In this plotting the data, we can see that the pyroxene rich lamprophiles mostly cluster around the ultramafic lamprophile type, whereas the pyroxene or amphibole rich type means the lamprophile mostly conform with the Deccan lamprophile types of the Indian subcontinent. This is a plot from the amphibole data. We can see that it reflects the primary nature of the amphibole, that is, they have been crystallized from the melt. This is a diagram for the classification of the amphiboles, which shows it is a magnesium hornblende type to cursatite type. And here in this diagram, we see the alkaline nature of the lamprophiles from the amphibole data. So now coming to the geochemistry of these dikes, this diagram shows that the lamprophile and tingoi, they are alkaline in nature. The lamprophile mostly fall into the alkaline lamprophile type. The samples conform to the mostly lamprophile type rather than lamprorites. Here we can see in this diagram, they are mostly metaluminous, and this is the data for the dolerites. In this diagram, we can see the negative correlation of MgO with the chromium and nickel values. And in here, in the chondrite normalized plots, we see there is a steep increase in the LRE pattern of the lamprophile, which again corroborates with the alkaline nature of the dye. In this diagram, this is from the tingoid data. It has a much steeper slope. It shows much more differentiation than the lamprophile. And coming to the dolerite data, these are mostly flat and shows much, and doesn't show much of the differentiation. From the trace element multi-element plot, we can classify the lamprophile rocks into two variants, two groups, some having a positive niobium anomaly and some having a negative. And also we can see a strong Ti depletion in one of the variants and not in the other. And here in this dolerite plot, we can see a typical niobium tantalum depletion along with a Ti depletion, which indicates influence of a subduction zone. This is a very typical example of that. So coming to the source rock characterization and tectonic setting, the biotoid-rich variant of the lamprophire have high RBSR value here in this sample. So they have shown affinity to be sourced from a phlogopite-rich source. Moreover, the pyroxene or amphibole-rich variety, they have a lower RB by SR value, and they point towards an amphibole-rich source, suggesting the presence of amphibole. Okay. All the mafic dyes focus under the continental arc setting and the within plate basalt setting. And here OIB setting you can see. And mostly they show slab dehydration type of generation, which is also corroborated by incompatible rich elements like rubidium, strontium, and barium. So we have carried out strontium neodymium characterization also of this dye. Here we can see these three triangles represent this dye. Mostly if we compare this data with the other carbonatite or alkaline rocks from the Meghalaya plateau, we can see that mostly the carbonatite sample from the Sung Valley, they cluster around this area, which has a low ND epsilon value and a positive and low, and ranges from 7.5 to something like that. But here you can see the samples from our study area, they show a large scale of distribution, mostly in the EM2, evolved mantle 2. That means they show enrichment pattern, rather which is in contrast with the carbonatite of the Sung Valley or Samchampi area. But these are similar to those of the silicate rocks that are found in this area. The silicate rocks that are gabbro, pyroxenite, these show a similarity with that. Moreover, here also it shows a similar thing pattern in this diagram also, strontium initial and the neodymium isotope. And these samples you see, these are of the dolerite sample. These show far more EM2 character than the other samples. This neodymium model ages we have calculated from the sample, and here we can see three clusters of ages can be seen over here. The first cluster is between 800 to 874 MA. The second cluster is from 1200 to 1100 MA, and the third cluster, these are the dolerite samples. This shows the highest TDM calculated ages around 2400 to 2900 MA. So from this, from the combined petrography, mineral chemistry, geochemistry, and the isotope data, we try to propose a model. Here, from the first age that we have found in the dolerite sample, we'd like to propose that there was an incipient subduction of the primary mafic crust. At that time, in this particular time, the depleted mantle subducted, and from this a localized zone of metasomatically enriched mantle was formed. This remained separated, detached in the subsequent event during this age, crustal thickening event, where subduction induced metasomatism started. Here also, again, in this period also, subsequent in the Gondwana assembly, there was an event of subduction and enrichment was there. And lastly, during the event of the Kerguelen plume upwelling, this age is actually from one of the lamprophire dike that was dated by Sarkar et al. In 1996 at 107 MA. So from this we have taken this age. So at this particular time, with interaction with the Kerguelen plume, these heterogeneous metasomatized mantle pods were melted, and these dikes were emplaced along the Nongcheram fault, which is the primary control along which these lamprophyres are found. So in conclusion, in this Wagesi, Rongjen, Nongcheram dike systems, we find lamprophyre tinguate dolerite showing distinct textures, mineral chemistry, and crystallization histories, indicating multiple magma batches and the chamber recharge, which can be corroborated with the petrography and also the mineral chemistry. Source characterization and magma type, lamprophyre ranges from anorganic, which are the camptonite, monchoquite form and amphibole-rich source, to orogenic, cyanide from the deeper phlogopite-rich slab influence source. This we have corroborated with the petrographic data From the Camptonite Monchiquat, we came from the CIPW norm we have done. Based on the CIPW norm, we have named the rocks over there, and we have corroborated with the deeper mantle, so RBSR data and the slab dehydration. Tinguites represent evolved alkaline melts where dolerites are tholeiitic from a depleted, less metasomatized mantle. Geochemical and isotopic evidences show that LRE enrichment, niobium-T anomalies, and EM2 enrichmental to SRND isotopic signatures indicate derivation from a heterogeneous lithospheric mantle, variably modified by subduction fluids and later influenced by Kerguelen plume melts. Mantle evolution through supercontinental cycle, distinct TDM ages, that is the neodymium model ages, of these three age groups record multiple mantle enrichment episodes linked to Colombia, Rodinia, and Gondwana assembly, now revealing a long-lived heterogeneous subcontinental lithospheric mantle beneath the Shillong Plateau. Integrated petrogenic model shows that formation of the first depleted SCLM, subduction-related metasomerism in this assembly formation events, plume-derived reactivation and melting of the heterogeneous mantle, and lastly magma ascent along lithosphere scale fault, that is the Nongcharam fault, collectively explain the generation and emplacement of these mafic dikes in a plume-influenced post-collision setting. Thank you.
Thank you, Bhaskar Jyoti. Now, again, any queries, any questions from the audience, please. Please, sir.
This swarm, dike swarms you're saying, what is the area, total area, and what are the host rock which is puncturing?
Yes, sir. I will just go back, sir, to the map, sir.
Yeah.
So this map, sir. These dikes normally occur along this line, sir. This is the Nongcharam fault, sir. These dikes occur along this, sir. So what, sir, during field work, what we have found?
Where is the Nongcharam fault?
Sir, this line, sir, the
And
dashed
where,
lines.
where are your dikes?
Sir, this, sir, this.
All the green ones?
It's a green, red, and blue, sir. Red is here, sir. A few reds are over here. And mostly, sir, 3 clusters we have found, sir. One in the Wagesi area. We have found,
wait,
sir.
wait. The one which were the stage 3 one, 1100 or 800, two stages you are given?
Yes, sir, yes, sir. Yes,
So they are lamprophires?
yes, sir.
So, but in the diagram which you showed, some of them was also falling with the lamprey at once?
Sir.
So have you checked the chrome diapsides, whether they have any chrome diapsides there or not?
No, sir, no, sir. We haven't found that, sir.
Um,
Sir, yes, sir.
Can-
Sir, your question is very much yes, sir, because we have discussed about that also in our during our work, sir. This, especially these lamprophile dikes in the Wagasi area, sir. These are, sir, camptonite and, sir, biotite rich, mostly phlogopatic.
Yes.
So the potassic content is also very high, sir. So we
Yes.
also suspected this could be, but because of, sir, lack of the mineral assemblage, means we have not done XRD yet on those samples.
So that is still a work
Yes,
to
sir,
be
yes,
done,
sir.
right?
Yes, sir,
So
that's
you
true.
cannot conclude,
Yes,
one.
sir, yes, sir.
And two, there's so many dikes, does it reflect on your geochemistry in the sense, does area has been geochemically mapped, NGCM has been done?
NGCM, sir, I don't know about, sir, might be done, sir. Yeah, might be.
So does it reflect on that? Does it reflect on the pattern of your geochemical pattern?
No,
of-
sir, no, sir, no, sir.
You have
no,
not
sir.
seen, then how do
Sir,
you say no, sir?
Sir, because why we're saying that, sir, the width of these dikes are very less, sir. And,
No,
sir,
but I don't know if the chemistry is completely different. You know, one is dikes are dikes, and your background is all
Gneiss.
granite,
Yes, sir,
gneiss.
gneiss, sir.
So there might be some even some spikes of some other.
Sir, because in the stream sediment samples, one of our objective was, sir, stream sediment samples also, sir. So look for any diamond potentiality, sir. So in that, sir, in those stream sediment samples, sir, around.
You have done what? You have done panning and what?
Yes, sir, yes, sir, yes, sir. We have done
And-
panning, sir.
And heavy minerals also.
Yes, sir, yes, sir. Sir, in those, sir, stream sediment, we couldn't find any, sir, any minerals like those are that can be linked with the dikes.
What minerals have you got in heavy minerals?
Sir, we got, sir, biotite, not phlogopites, sir, and we got like
Any heavy minerals?
heavy minerals we didn't get, sir, like, sir, pyrite, magnetite.
Okay, and one of the diagrams you showed magnesium and nickel, they were negatively correlated. I did not see that. Where is the negative correlation there? Yeah, the last one.
Sir, sir, this actually we wanted to say that because of olivine differentiation was there from
No,
this
where is the
sample.
negative correlation? It appears to be positive correlation. No, this is the one.
This one, sir.
Yeah, it appears to be positive correlation. Why is it
Oh,
negative?
sorry, sir. Yes, sir. It is positive, sir. It is, sir. No, it is, sir, 0. Yes, sir. Those are increasing, sir. Yes.
So how is it negative? It's positive correlation, right?
Yes, sir. Yes, sir. It's positive,
so,
sir.
So your interpretation is both ways correct. Even if it's negative, you have the same interpretation. Positive, same interpretation.
No, sir. No, sir. Actually, while saying it means for my answer was mistake, sir.
Yeah, just okay. That's my. I have many other questions. Let it pass. I will talk to you later on.
Sure, sir. Sure, sure, sir.
So I am DJ Dasgupta, and incidentally, it's not a question. Incidentally, this dikes, the lamprophires,
Yes, sir.
they were located by me and Mr. Golani
Yes, sir. Okay.
in 1984
Yes, sir.
field season.
Yes, sir.
So after that, and that time we didn't have these facilities. Even petrology was a big issue.
Sir.
Doing petrology was a big issue. That's why Nambiar couldn't carry on further.
Yes, sir.
And chemical analysis was out of question. Those days it was very difficult to get anything from Shillong, and we had to approach Calcutta, CHQ, for these petrographic, for the slides and also the analysis.
Sir.
So that is the reason why this work could not progress at that point of time.
Surely, sir. Surely, yes, sir.
Bhaskar,
Sir.
one or two small things. You are talking about pyroxenes
Sir.
and quadrilateral pyroxenes dominantly.
Sir.
Quadrilateral classification.
Yes, sir. Yes, sir.
But you also have sodium pyroxene, non-quad.
Yes, sir. Yes, sir. Here, sir.
But you are not talking about them.
Sir, actually, I wanted to maintain the time. That's why I skipped. Means I went fast, sir. These pyroxenes, sir. So we have classified
No,
actually.
This is not the quad.
Okay.
That is the quad diagram where you remove. That is not wollastonite, huh?
No, no.
On
We
top.
can remove this, sir.
Yeah,
Totally,
so
sir.
that
we
then
can-
it becomes a quad,
Yes, sir.
quadrilateral.
Yes, sir.
So this is quad, but there are you have sodium.
Yes, sir. Sodium
there.
pyroxene also, sir.
And they are not finding a mention other than in petrography.
Yes, sir. Yes, sir.
But they are important.
Yes, sir. Yes.
Similarly, when you look at the amphiboles, are there any sodium-rich amphiboles? Not sodic, sodium-rich.
No, sir. No, sir. We haven't found, sir. We
You
haven't
don't
found
find?
yet, sir. Sir,
Okay.
the work what we have done till now, sir, we haven't found, sir.
Okay, so that could be very interesting. There is only one comment I have on.
Sir.
When you look at 3 stages, 3 times subduction,
Sir.
every time at the same place, are there anything like that which has happened earlier anywhere else in any tectonic situation? That you have the same boundary practically or same domain where separated by a few 100 million years and you have subductions repeated at the same, almost at the same place when you reconstructed, na?
Yes, sir. Yes, sir.
So please think about
Yes,
it.
sir. Surely, sir.
You
surely.
understand that it is not a very likely situation.
Yes, sir.
Spread over
Sir-
several 100 million.
Sir,
years.
actually, sir,
Huh?
sir, the dating of this rock, sir, only one sample RBSR was done, sir, by Sarkar, sir, in 1986. So after that, sir, the tinguites have been found, and dolodites are still not yet dated, sir. What we have seen, sir, 24 to 2900 MA, TDM ages. It is very absurd, sir. It is very old age, sir. So while consultation with my colleagues, and from where we have got this data from NGRI, sir, the scientists over there, they suspected that it is type of a fossil pod which was left unmetasomatized. While discussion,
Yeah, but
for that
still-
reason it is showing that age, but that is not the actual age.
No, but the model which you built, you showed us.
Yes, sir.
At the same place, it happening repeatedly
Yes.
over a very long period of time, where Gondwana to subsequent 100 million year old and
Yes, sir.
very old. So everything happening is not a very.
Sir.
I mean, it needs to be seen whether it
Yes,
can.
sir. Sir, as you can see, sir, in the same area, sir, these carbonatites, the SR&D isotope, they are falling in a very good cluster. But in the same sir, area, you see the silicate rocks, they are showing this array.
Yes.
So definitely, sir, these rocks were not from the same source. They are forming in the same complex we are getting them. all this, let alone, sir, if you forget about my samples, if we consider about the samples of the Sung Valley, where extensive work has been done, sir, in that area, we can see that these rocks, the silicate rocks, gabbro, pyroxenite, they have been, sir, they are showing a very large array, and these are not. So this also gives us an indication. What we are suggesting, sir, this also gives us an indication that this type can only be from a heterogeneous mantle. If there is a heterogeneity, then only this array will.
Or it could be different different amount of crustal
Yes.
mixing.
But the participation of the
yes. So it could also be from that.
From that.
Even for Rajmahal group, which you have shown, is a significant amount of variation.
Yes,
where it
sir.
is a single source.
Yes,
remember?
sir. Yes, sir. That's why,
So
sir.
there also it is not less the range which has been shown in this diagram.
Yes, sir.
I am only saying that the geodynamic model
Sir.
should be realistic, whether it is possible or whether it can be possible or not, or whether similar things are reported elsewhere, then
Sir.
it helps actually.
Surely, sir. We'll take into account.
Thank
sir.
you.
Thank you, sir. Please, mic, please. Sir. Please.
Hello. The stage 3 lamproids, which are dating as 1200 or something, no?
Yes, sir. Here, sir.
That is broadly coinciding with your Vindhya and kimberlites.
Okay, sir.
So you be careful of that. You might be land up with good diamonds there.
Sir,
So
we have
leaving your diamonds there.
Sir, firstly, sir, from the stream sediments we haven't found anything, but
No,
we
go
have.
for you have got the exposure of the lamproids itself. So why go for stream
No,
sediments?
sir.
Go with that.
Sir, from the geochemistry also, there is a particular plot from Birkett et al., sir. From the first transition element, they have published a paper on the diamond potentiality, sir. In our report, we have mentioned that also. We tried it also. We collaborate to corroborate with the fertile lamproid samples. Are they fertility is there or not? But they were also not showing any, sir, fertility in this. samples.
Try again. You never know.
Sure,
You
sir.
should
Sure.
not leave your diamonds.
Sure, sir. No, yes, sir. These are not the edges, sir. Yes, sir. Mental, sir, models, sir. Models. These are. Yes, sir. From that only we are trying to say that at this particular age it got separated as a metasomatized pod. It got separated from the mantle, a particular pod.
This is not the plumage. You said this is a plumage, no? Plume induced melting.
Sir?
Isn't that the plumage?
No, sir. That is not a plumage. That is an emplacement edge of one dike from that area.
Okay, that's same. Okay.
This 107, sir. This is.
No, I'm not saying the 107. I'm bothered about the 800 and the 1100.
No,
ones.
sir. That is not a plumage, sir.
Okay.
Sir. Sir, please. Sir.
Now you said that your lamprophores are practically falling in alkaline lamprophere.
Yes, sir.
But I find they are also falling in calcareous.
Yes, sir. Yes, sir. Few, sir. There is an overlap. Surely, sir. There is an overlap. That's why we are saying, sir, there is a dual nature is there, sir.
Shilaita, you please put on your mic. It's not. You're not audible. No, you're not audible. You're
No,
not
sir.
audible.
No, sir. Your mic is.
Hello.
Yes,
Now it's
Sir.
no. So that is one point. You please take care.
Sure, sir.
And another one is, I mean, you could have plotted the biotite and biotite lamprophore and pyroxene lamprophore in that itself, in that diagram.
Yes, sir. We
You
have
just
done that, sir.
you have not done that. Okay, I think that what sir was telling about this, all these ages,
Sir.
if you take all of them as all different, I mean, episodes of, yeah,
Yes, sir.
that becomes little difficult to this thing, and this is not impossible to have a array of this isotopic signature, strontium versus Nd.
Yes, sir. Sir, from this data, we are not trying to say that this is the age of emplacement. We are not trying to say that. We are trying to say the metasomatic pod from which these dikes came out at during the Kargulian plume event. Sorry, during the Rajmahal and the Sylhet plume event, these pods were separated from the mantle in these particular periods.
No,
Means
that is how you want to, I mean, put them in different episodes of orogeny, no?
yes, sir. Yes, sir.
All together.
Yes,
That is where the
Sir.
question lies. Even a single orogeny also, the array can be different.
Sir.
Since you have completely, not considered about the, or of the continental, or sorry, crustal influence in
Sir,
those things?
Sir, this particular age, sir, we are also, because, sir, we have found from J. Kumar et al., sir. In this area, the NICEs are there. Inherited zircon age, they also have reported of 2400 MA. The zircon age of the granite is around 1700 MA, sir. In that, sir, they have they have reported about 2400 MA sir, inherited zircons. So we try to correlate this age by saying that at that particular period there must have been some rocks over there which were dated like 2400 MA. So this event might have happened.
2500 MA zircons are abundant all over the world.
Sir, in that
That is
area,
one event. That
sir,
is one event, I mean granite.
sir.
That is one event which is actually everywhere, and this also has the.
Even some of your granitoids or granite gneisses of AMGC,
Sir.
they are also having those, those inherited zircons.
Sir, actually, what I was trying to say is, एक discussion ऐसा हुआ, one was their discussion. I am saying we are trying to say that at this particular age there was some event, whether at that period of time there was any crust over there or not. What I am saying over here, there was an episode in the mental in
Okay,
which.
I think, okay, I mean, we got your point.
Thank you,
So
sir.
let us, those are the points which have been just brought in front of you. You please think over them.
Sure, sir.
And
Do find some diamonds.
Sure, sir. Thank you, sir. Sure, sir. Thank you, sir.
I think we come to the close of this session in that case. Sir, any concluding remarks from your end?
I think we have had good discussion in every session, every question. So, and probably is there, no? So I think tea time is also approaching, which is more attractive than listening to, repeated listening to us. So I think let us thank all the presenters, thank the presenters who were not present to give us more time also, though we miss them, of course. And we are very thankful for a reasonable presence here of the audience. They are to be appreciated more, so let there be a clap for all the audience there. Thank you. Thank you.
So, with all the presentations now concluded, I extend my sincere thanks to all our speakers once again for their valuable contributions. So, may I now invite Ms. Sonia to kindly felicitate our session chair, Professor Naresh Chandra Pant, and our co-chair, Shri Sheeladitya Sengupta, with mementos as a gesture of our sincere appreciation for their guidance and support in this session. Thank you, sir. So, with this, technical session 1 comes to a close. I extend my heartfelt thanks to all the participants, speakers, delegates for making this session truly enriching. We will now take a short break, and you are warmly invited to proceed for high tea near the banquet hall. During this time, we encourage you to visit the poster session and exhibition as well. We will start with the technical session 2 at 5 p.m. Thank you. I request speakers presenting in technical session 2 to kindly upload their presentations. Thank you. A small announcement. Speakers who have not yet uploaded their presentations, kindly do so for the technical session too. Thank you. नहीं ले लिया था मैंने. Thank you मैम. ठीक है. So we'll be proceeding with technical session 2. Ladies and gentlemen, esteemed delegates, we now move to technical session 2 dedicated to the theme Geohazards Decoded, Research for a Safer Tomorrow. This session focuses on understanding, assessing, and managing the geological hazards that pose significant risks to communities, infrastructure, and sustainable development. Our speakers will guide us through a wide range of important geohazards issues, starting with India's landslide challenges and how they can be better understood and managed. We will then look at studies assessing environmental risks in river basins, followed by work that helps us understand the stability of our rock formations. The session also brings insight into improved methods for predicting landslides and identifying areas vulnerable to multiple hazards using modern analytical and geospatial tools. Together, these studies highlight the scientific foundation required for building safer, hazard-resilient environments. Let us begin this important session. To guide this session, we are honored to have with us chair for the session, Dr. Saibal Ghosh, DDG and NMH4 GSI, an eminent GSI scientist and national mission leader with over 3 decades of pioneering work in geological mapping and landslide hazard assessment. And I would also like to extend warm welcome to our co-chair, Shri Manish Khar. He is currently the Deputy Director General at DGCO GSI, New Delhi, with wide experience across specialized mapping, mineral exploration, seismic microzonation, landslide studies, and policy support. He has also served with the National Mineral Exploration Trust, contributing to the key national geoscience initiatives. May I now invite Dr. Saibal Ghosh and Shri Manish Khar to please join us on stage. Thank you, sir. Also, I would like to request Shri Anindam Gatayat, Senior Geologist, GSI CHQ Kolkata, and our reporter to come on the dais to record the proceedings of this session. To open this session, it is my privilege to introduce Dr. Saibal Ghosh, a distinguished geoscientist with an exemplary career spanning over 3 decades at the Geological Survey of India. Dr. Ghosh has made outstanding contributions to geological mapping, engineering geology, and landslide studies throughout the Himalayan as well as in Bhutan. He currently leads the National Mission on Fundamental and Multidisciplinary Geosciences at GSI. Dr. Ghosh holds advanced degrees from IIT Kharagpur and earned his doctoral degree from the University of Twente, the Netherlands, specializing in empirical prediction of landslide hazards. His academic impact includes 30 plus publications, a citation count exceeding 900, and significant contributions as a reviewer for international journals. In recognition of his impactful work, he was awarded the National Geoscience Award in 2022. He is also the Vice President of Indian Society of Engineering Geology, the India National Group of IAEG. Ladies and gentlemen, please welcome Dr. Saibal Ghosh, who will now deliver his keynote address on the Indian landslide hazard scenario, types, processes, mitigation, and management challenges.
Thank you. Namaskar. Let me start with my topic. You can understand, obviously, though I will be delivering this talk, but this is a talk where nearly my maybe 100 odd Geological Survey of India colleagues who have generated data after putting very strenuous field work in the Himalayas in other parts of the country. I am just presenting their work, being the national mission head before you, so that you can understand what is the actual landslide hazard scenario of our country, what type of landslide processes are present in India, and what are its challenges. Let us talk about the global and Indian scenario so we can understand. So this is a work everybody knows done by NASA, and it's a World Bank report based on a very long period of data, 1980 to 2080, and you can see the condition of Indian extrapeninsular area. So you can understand the landslide hazard scenario, what is the conditions of this entire Himalayan belt, the Western Ghats. So, and also the another very important point is that based on this background, if we see now our Indian data, then you can understand and appreciate that how accurate this assessment is. But one interesting aspect just I want to touch upon, that in the same report, because as you know that landslide is caused by two types of factors mainly. One is intrinsic predisposing factors, that means slope morphometry, geology, land use, which are static basically, and it is being triggered by various triggering factors, and one of the most important triggering factor is rainfall. So in our country, since active monsoon period are mainly between June to October, but in the Western Ghats and in the southern peninsula, southern areas, we also are affected by northeast monsoon also. So the landslide is affected till January of any year, or next year you can say, starting from the early part of June. But it has been observed globally that there is a sharp increase in the frequencies of rainfall induced landslides post, you can say, 98, 97. It's quite significant increase. And if you see this particular plot, you will see that Southeast Asia is actually contributing the most. Why? Might be the reason that China, India, Nepal, all these places, there are huge infrastructure development which are coming up in the mountainous areas. There might be some connect into this. So if we go to the next slide, so we can see that what is the basic landslide scenario of our country, because there was a huge deluge and disaster in 2013 in India, which is known as Uttarakhand disaster 2013. Before 2013, the country was having isolated maps of susceptibility in different basins in the Himalayas, but no pan-India database was available. So GSI thought that we must launch a national project. So the National Landslide Susceptibility Mapping Project was launched in 2014, and a very systematic way on 50,000 scale, we developed or created this database. We worked till 2022, and we have completed this landslide susceptibility map. Basic data is on 1:50,000 scale, but the landslide inventory is scale independent, you can see, you can tell, because we have collected data through field. So even a smaller landslides, because if you go by the landslide definition, there is no restriction of size. So any smaller landslides collected, data collected by our officers are also included in our inventory. And so far we have also inventoried nearly 107,000 landslides, and out of which the most interesting thing is that the 34,000 landslides are studied in field by our officers, where we have collected around 42 different geoparametric attributes for each of the landslides. So we have a substantial amount of landslide processes information in our database. Now if you see that this database has given an idea that around 19 states in our country are highly landslide prone, you can say, and out of that you can understand all these states are in the Himalayas, and all these states are having very high proportion of high susceptible zones, more than 10% at least. And the most highest is, as per our record, is Himachal Pradesh. It is nearly 29% landslides are there, and not landslide I should say, 29% area is highly susceptible in our map. If you come to the sub-Himalayan northeastern regions, then these three states, Manipur, Mizoram and Nagaland, are quite affected by landslides. They have also very high proportion of high landslide susceptibility zones. And in southern regions or in the western Ghats, Maharashtra, then Tamil Nadu, then Kerala is extremely affected. Around 13.1% area are highly susceptible. And this blue line actually indicates the landslide inventory distributions. And you can see the last database we had of Arunachal Pradesh was a database created by remote sensing agencies in 2004. That was the earliest database we had on Arunachal Pradesh. They inventoried that time around 5,000 landslides. But now you can see this work we completed in 2022, and we have nearly 26,000 landslides inventoried in Arunachal Pradesh alone. This is another hotspot coming, because in Arunachal Pradesh also we are doing lot of infrastructure projects coming up, lot of roads are coming up. So you will see that this factor, these things will also increase, because now we are also updating, because some of the data of these maps were prepared in 2014-15. So now almost 10 years have passed. So every susceptibility assessment needs to be updated when a new event has come or when a new data has come. So we have also started updating some of the maps. Now if you see the density, you will get a peculiar picture that these two states, Sikkim and West Bengal has a very small two districts, that is Kalimpong and Darjeeling, which is highly landslide prone. And Sikkim, they are having the highest landslide density number percentage. That means per square kilometer number of landslide is extremely high there. So this is also another parameter you have to look into when you are considering the hazard of a particular state. Now coming to this, now since a pan-India database is ready with GSI, now we can tell district-wise, subdivision-wise, what is the potentiality or hazard potentiality of this country, that how many districts are there which are having more than 25% high zones, like that these estimates are there. And this is the basic fundamental baseline database or geodatabase which should be used for infrastructure planning, that we are always suggesting to our state government, NDMA, SDMAs, that you please utilize this data. This is a very valuable data where you can plan your future infrastructure. Now this is another very interesting picture, though this database is not a consummate database, I should say, because we have one project called post-disaster landslide studies. What is that? Every year after monsoon, our officer used to go to field and collect that year's landslide occurrence data. And also they give more reliance when there is a call from the state government, because you see, people are more interested to map those or to collect data of those landslides which actually affects the settlement, infrastructure or element at risk. So those things are being taken into consideration. So I cannot say you that these landslides are the total number of landslides of that country, but this is a very good estimate of data. If we leave the Kerala incident of 2018, this was an extreme event where we have nearly field validated data of 2000 above landslides in 2018, you will find a slight increase in the landslide frequencies also, but number of data also. Because I used to get lot of questions from the parliamentarians every year that please tell us whether number of landslides are increasing or not because of the climate change extremes or not. So to some extent this data can give you an idea. And next I am coming to the types and processes. Our country is having almost all these type of landslide processes, shallow translational, very large landslides, then very deep-seated rotational landslides, then very big debris flows. Now debris flows are creating a lot of problems. Just I wanted to tell you one thing, those who are working on landslide, they can understand. Landslide susceptibility mapping actually model the areas where from landslide can be initiated. But it cannot model where it will go and impact. So this is becoming a challenging areas that people living in a very low-lying area but affected by a impacted. These Churmala landslides, you all know, the single event took 450 lives, more than 450 lives. And these areas are not highly susceptible areas as far as initiation is concerned. But these are very highly susceptible area as far as debris flow impact is concerned. So now when we are updating our map, susceptibility map, we are adding this data also, and we are updating map along with the initiation susceptibility and impact susceptibility together. Now coming to the types, whatever types we have, because we have the data of 34,000. We do not have the data which are, we have not analyzed, we have given reliance on mostly the field validated 34,000 data. From the 34,000 data, we have seen that in India, the debris is almost 50%, the material debris is around 50%, and there around 35% are material is rock. And if you see the type, definitely slide is the predominant portions as far as the movement type is concerned, and followed by others. If I see the failure mechanism wise, definitely the shallow translational slides are around 10.5%, 79% slides are mostly planar. These are wedge type of slides. This may be rock or maybe debris, this planar one, not this one. And 5.6% are complex, having complex mechanisms, and deep rotational slides are really not much. And distribution types you can see, most interesting is that we have tremendous amount of retrogressive landslides in India. This is very, very important as far as the Himalaya is concerned. Himalayan landslides are, our experience says that a landslide always try, if it is not contended in time, then it will show, either it will, the crown will move upwards if it get a chance, if it has not reached the top. If you see the size and magnitude, we have all sorts of size. This is a picture, this is a very good account we have taken from landslip. So to make a common people understand about the size, we are not going by very measuring tape and compass and other things, but it's a very simple thing. The landslip project people have done, it's excellent. Lot of landslip, our project partners are still here in this room. And this is a very simple projections. We have seen that most of the landslide, this was done on the basis of the GIS from the 1 lakh, more than 1 lakh landslides, and about 56 cumulative percentage landslides area is less than 100 square meter or lesser. So that means what is the message in this that the large landslides are very few, only 8% or more. And another interesting thing about, if you go in our Himalayan areas, you will find that our susceptibility zones, landslide, these black dots are nothing but landslides. These landslides are highly having very high spatial association with the road. Why? The data, road we have not plotted later. We have not taken into considerations earlier, but we have, when we have plotted the road, we have seen, because if you see, Himalaya is rising 3 to 4 centimeter every year. So if you see that most of the roads are aligned along the trunk river system, which is flowing from north to south. Now in the trunk river system, it is always easier if we align the road along either of the bank of the trunk river system. All the national highways of the Himalayas, you will find that it will following some big river system channel. And near the river system, it has always a tendency, because if the Himalaya is rising seismically 3 to 4 centimeter, then all the water system, all the drainage system will try to achieve to the to the more low energy level. So always we are finding that near the river there is a hump like structure where the road, that is the toe of the hill mass. This toe of the hill mass is always disturbed, and this disturbed hill mass is creating lot of landslides. This data is also showing that thing. And another very important thing, if we see in our Himalayas or in our mountains, that all the settlements are always being concentrated around that road. Road is the one of the most important lifeline, and it is actually, if road is affected, then infrastructure or element at risk is also affected. Then you can see that how the lithology changes, and there is absolutely no protection given. So there might be initiated from a simple road cut slope, but a big landslide has happened. Then if I go to another examples, you can see the conditions of the rock mass. This is a bedrock, but this is, if you see, this is just like a soil. It has no strength. So in that, such a steep cut, if it is not protected, will not stand much. So that is happening in the Himalayas in many areas. Now, coming to that, what the country, what we are having, as I told, we are having on 1:50,000 scale, 4.3 lakh square kilometer entire landslide susceptibility map, along with the landslide inventory, out of which around 30% inventories are field validated with, rather I should not say field validated, it is field studied. And apart from that, out of this data, now we have since 2018, we have started making more upscale data. So we have transferred our analysis to our mesoscale systems or mesoscale studies, which is 10,000 or 5,000. We have selected around 200 sector, priority sector, in discussion with the state government and the NDMA, and out of that 160 sector we have completed by this field season. And apart from that, in the last 5-6 years, we have also studied 53 critical landslides on 1:1000 scales also, for suggesting to the state government or the stakeholders to employ or to put the site-specific remedial measures. In the last 2-3 decades, GSI generated a huge amount of database, around 1,118 reports. And these reports are freely given to all. I will show. You can also download from this site. You click it, and you can download it. And I will also, though in this lecture I did not keep much on landslide early warning, but I just tell you that in 2020 we have started testing a prototype model which was developed by Landslip, where GSI was also an important partner, along with CNREP, in Newcastle University, then King's College London, then Amrita University, lot of consortiums partners were there. And we developed a prototype model for 2 districts, Darjeeling and Nilgiris. And from 2020, GSI has started testing it on the ground. And I can tell you that till today, we have operationalized in those 2 districts after 3 years of testing. And also we have extended this model with site-specific changes in 21 districts currently. We have also created or established a exclusive center at our headquarters at Calcutta, National Landslide Forecasting Center, NLFC, where this entire work is being coordinated. And now about 17 districts we are giving experimental bulletin every day during monsoon. We are issuing this bulletin. It is going to the district magistrate, to the local SDMAs, and also we are giving to IMD for testing this. And 4 districts, Darjeeling, Kalimpong, Nilgiris and Rudraprayag in Uttarakhand, these 4 bulletins are been made operational. So this is the steps we have taken so far. There is a huge demand from the government to extend it, because we have 181 districts which are landslide prone, and out of which around 90 to 100 districts are highly risk prone. So government is wanting us to at least extend it as fast as possible, so that by the end of Sendai framework in 2030, at least each landslide prone state should have a regional landslide forecasting in place. Now, this is a portal which GSI has developed exclusively for landslide. This is Bhusanket portal, and this Bhusanket portal, you can see this report, you can download state-wise report, the PDF easily. Anybody can download it. This entire database also is downloadable. Anybody can download it. A GIS-enabled database we have kept in NGDR portal and in Rupos portal. And this is our mobile app. We want everybody should use this mobile app. It has two options. This mobile app has, one is for a normal, non-expert users where 7-8 point, because you think one important data is missing everywhere in the country and also in the international many countries, the landslide actual date and time. This is very much required. So this is possible only if this crowdsourced platform are being used by everybody. So this is very, very important platform, and you can see if our GIS enabled data, these are all non-GSI users. Nearly our susceptibility map have been downloaded by 15,000 times, and our landslide inventory have been downloaded by 28,000 times, and these are all non-GSI users. We use all this data, we also download, but people from, and we share this data with the NDEM portal. One national portal is there, is maintained by ISRO, and also with NDMA portal. With every data GSI is generating is shared with the state government and these things. Now I'm going to discuss a few things about the mitigation and management challenges. These are very interesting aspects. I want to tell you what are the problem in India. See, this landslide is a famous landslide which occurred in 2021 called Nigulsari in Himachal Pradesh. And it killed, I think, 3-4 people in this landslide because of the rockfall. Immediately state government called GSI to map, do the site specific work. We did. 2021, we did the entire site specific work. We submitted the report 2022. But somehow we could not, our state government or central government, whoever in this charge of putting the remedial measures on ground, could not employ that. And now this is the condition of 2025. As I told, the Himalayan landslides will not sit idle. This is very, very important message. That's why in our database around 45% landslides are showing a retrogressive nature. We have experienced it in my 30 years of work. I have seen in Himalaya how the landslides evolve. This is a very interesting example. Lot of people have worked on this. This is Dharali. You have might have heard in Uttarakhand there was a debris flow along this Khirgad. Suddenly this debris flow, this is the situation before August 5, 2025 this event occurred, and you can see a perfect copybook example of alluvial fan. Now forget about these two pictures, see the picture of earlier period. What is this? This is nothing but an old alluvial fan. And you see in 2011 there was very few houses here, not much. And slowly lot of settlements are coming up on this, and here also settlement has increased. And unfortunately in 2024 GSI worked this area. They have suggested that this is, because the upstream of this Khirgad in our susceptibility map has been identified as the very high susceptible zone, source zone. So the source zone is there. We have studied in 2013-14, we have told that this area, especially the left bank of Khirgad, is more dangerous. So we have suggested to raise some wall and not to increase any settlement there. But somehow we miss this. So this is another example of a landslide. In 2003, the crown was around 200 meters below the national highway. It was in Darjeeling. In 2006, what happened you can see. Then 2010, 12. Then we have studied this landslide at least 2-3 times, even on large scale, site specific scale. We have suggested here the rail and road authorities somehow implemented some of our suggestions. And you see the situation of the landslide, it is slightly, so all these big landslides require some help from the human people. Then it will naturally, in Himalayas, land use changes are very rapid. So automatically if you allow some protection measures, then it will slowly adjust. This is one example. Another examples we missed, this is another examples we missed. These examples are many in India, but I just wanted to show you some success stories. This is a big landslides occurred in 2003 above a hill town called Uttarkashi. This is Barunabad landslide. And Barunabad landslide, after the landslide, lot of agencies including GSI worked together, mapped the entire area, and a very extensive remedial measures have been put in 2007-8. And you see, last 16 years, there is no problem in Barunabad landslides. This is one slide which is known as Kaliasore landslide. I think many PhDs have been done on these landslides. But in Himalaya, not all landslides you can tackle. So here we have to take a decisions that whether we will, that geologist cannot take decisions alone. In 2005, our people told that let us avoid this landslide through a short tunnel. Government tried, government did not try for tunnel, but government make another road alignment on the other side of this river, but that was also putting, creating a lot of problems. But one success story is here. Here I worked during 2005-6. This is Sikkim, a very steep rock slope, fall zone. Here, when the border roads approach to us, then we told that it is impossible. You know, even here, I was about to had a very bad fatal accident. I was that day, if something would have happened, but somehow I saved myself. Now you see one short tunnel of 579 meter, whatever we have suggested, exactly implemented by border roads, and this area is avoided. This is most important. I was discussing with my Italian colleagues. So you see, you have to give more importance to the geology of that area. In Himalaya, if you see the geological map of the Himalaya, the lithologies are trending mostly northwest. In this northwestern Himalaya, I am telling, northwest, southeast. That means when you are actually, all your roads are from south, from the plain land, you are going up from south to north. So you are actually cutting across different lithologies. And the lithologies are different. And Himalaya has huge number of shears, fractures and faults. But if you have a similar type of excavation pattern, similar type of road construction strategies, then there is a problem. So you see, this is one of our 10,000 scale work in an area, and how many close observation point and geology we have picked up. So you have to give reliance to all these things, and then only the landslide mitigations things are possible. The same area, you see the different lithology. This is maybe a competent quartzite. This is a dolomite which is also highly fractured and sheared at places. You can see this year the rock conditions is very bad. So what my message I want to tell, that geology, slope morphometry, structure, you have to give reliance to, and then only you can do all sorts of. Otherwise, it is not impossible to build infrastructures in Himalayas. It is not impossible. You can build. Engineering, civil engineering has advanced like anything. And another big problem, I think my international colleagues will appreciate, that we have seen that for Italy, they have developed the early warning on landslide, like the same model which we are trying to develop. And I think they have very well dense network of AWS or rainfall stations. But in our country, in the hills, the density is 1 in around 850 square kilometer, which is very, very sparse. This has to be increased. This has now Government of India has understood, and they are putting a lot of endeavor on this. So the triggers and lessons learned, in the recent years, we have seen that extreme weather event frequencies are increasing. Along with that, another big problem is coming on the Himalayas is lough and glove. That is also dangerous, and when it comes, it is actually having some sort of a domino effect or multi-hazard effect, where it is creating bank erosions and toe erosions, creating another landslides. So it has a lot of effect. Road construction and widening within poor geology and lack of timely slope stabilization is a big problem. We are creating a lot of landslides. Settlements increasing in vulnerable zones, that has to be stopped through land use zoning regulations. What is the way forward for us? That we have to update the 50,000 scale map, and we have to strengthen our regional landslide forecasting system to cover all the prioritized districts. And we have also done some sort of collaboration with ISRO, where we will be applying the SAR interferometry for the ground deformation monitoring also, so that a large area can be monitored. That also we are planning. And stress more on collaborative research with road sectors. We are helping them. A lot of DPRs are now coming to us. We are commenting on those DPRs, so that hopefully in the near future they will be more careful. And this is a policy level interventions in India is required, maybe a challenge for all countries, that still these policies are not there, that GSIs, these pan-India, these products and 50,000 scale product or 10,000, 5,000 product should be integrated in the planning and regulations. That is still not there. We have to increase the density of ARGs, AWS, and also Doppler radar network in the Himalayas. An active and major landslide in high risk zone needs site specific mitigation on priority and timely mitigations. And that's why we have recently given these suggestions to all the states, that you prepare a special purpose vehicle in each state, give some more money to them and take some work, and GSI will help them. Thank you. This is our bulletin which we are giving every day to all the, this is one in Nagaland we are issuing. We have just closed on 15th, because all the places the monsoon have been withdrawn by IMD in the Himalayas. We waited for around 1.5 months, then we have stopped it, because now we have to analyze the data. And if there is a disturbance, we have taken a policy that we will again start for period of disturbance and these things again bulletin. Thank you. If any question is there, one or two, you can ask. And otherwise, since we have only 2 speakers, so we will, if you have any questions, you can ask. Or
sir, good afternoon. What could be the reason behind that Ladakh falling in the high susceptible zone, but
lesser number of landslides?
Yes.
Very good question. I was expecting these questions. You see, Ladakh, if you go Ladakh, it's a dry desert almost. Here the action of water is not much. If you remember, I think in 2012 or 11 there was a debris flow or mud flow there. So actually, and another, this is one. Another thing, not much road constructions have happened there. The area geologically on the static regions and the predisposing regions, the area has very loose and very unconsolidated material. Sedimentary formations are mostly there. So that way the area is highly susceptible. But I have told you, landslide will happen only there is a trigger. If the trigger is absent, then landslide will not happen. Here might be the trigger is much weaker. But if you start developing without giving cognizance to this, then definitely that we have experienced in Arunachal Pradesh. Arunachal Pradesh number of landslides are increasing every year in a phenomenal manner. Yes, yes sir.
Mauro,
no, Fausto Gujati.
And he was talking about that there is always, it is not required always to have a trigger. Something like that he was hinting at.
I may miss that.
Trigger or I might have wrongly understood.
You need a trigger.
Always.
Huh?
Always. Achha, but I think he was talking
no,
about
he was telling something else. I think he was telling that the landslide sizes will not change because of the increase of trigger or nothing. That he was telling. Okay. Landslide sizes have a peculiar thing. It has a power law distributions, and as you go to the lower size, there is a fallback of the power law curve. So that means this might be a natural thing, or might be explain that you are not able to map these smaller landslides. But in all database nowadays, smaller landslides are mapped. But we have seen that the density distributions of the lower fractions, it was increasing, but suddenly it will, after beyond a size or lesser than that size, there is a drop. So he was telling this phenomenon will remain same if there is an increase in. This is a, I think.
It is irrespective of trigger.
Irrespective of trigger. So trigger, yes.
And one more thing. One more thing is regarding this. We are issuing daily one bulletin.
Daily one bulletin for all the districts of 21. 4 operational districts we are disseminating through our portal, through our mobile app, through all the means. But for the 17 experimental districts, it is going directly to the district magistrates and the principal secretary to the SDMA. Because we still not able to do it public because it is not properly tested, ground tested. But we generally keep some 3-4 years time and then certain parameters if we get. That question I asked Fausto in the morning, but Fausto a little bit deviated and could not give the answer. I know that it is very difficult to give that answer. But I think with they are our partners in this crime. So for the landslide forecasting, so we will definitely develop. Landslip has suggested some KPIs for when he will go from experimental to the operational, but we will be refining it further, but it has to be site specific. The same KPIs will not be same for Darjeeling, for Uttarakhand, maybe not the same. Yes, Maria.
Yeah, thank you very much, first of all, for your interesting talk. I was wondering, because you show here the bulletin for the landslide, rainfall-induced landslides. I was wondering, what is the contribution of earthquake-triggered landslide, especially in the Himalayas?
Not much. Maybe earthquake is inducing some places. There are some examples. Because during the Gorkha, last major earthquake happened, the Gorkha earthquake of 2015. Lot of landslides happened. In Indian part, not much, but still we invented it. And there was one event in 2009 in Sikkim. There was a 6.8 earthquake in Sikkim, where GSI invented nearly 150 landslides, which are completely earthquake induced or earthquake triggered landslides. But in our country, our database is telling, one database you know about that, I think from Southampton University, that database, they were telling around 77% is having a connections with the anthropogenic actions, but or the rainfall triggered landslides in India. In our database, we have seen around 84% landslides are rainfall triggered. There are few purely anthropogenic. People cut the toe, landslide happened. Then river cutting the toe, landslide happened. And but definitely, if there is no monsoon, landslide will be lesser. But that will create a lot of problem for our country as far as food security is concerned. Thank you. I think we can invite our next speaker.
Thank you. Thank you, sir, for enlightening us with your expertise. And we now hand over the proceedings to our chair and co-chair to lead the session. We have 4 presentations ahead, and I request all the speakers to kindly follow the allotted timeline. 10 minutes for the talk and 5 minutes for discussion, so that we can remain on schedule. Chairs, the presentation order is placed on your desk.
Yes, I have the geochemical assessment of source characterization potentially toxic elements. Shyam Konar. Please. इसको ऑफ करो ना
Okay, so good evening to all the distinguished guests, delegates, and my seniors and colleagues. So I'll be presenting on the geochemical assessment and source characterization of potentially toxic elements, or PTEs, in stream sediments of the Belan River basin, which is in the Ganga plain. Belan River is basically a southern tributary of the Son River, which is again a southern tributary of the Ganges or the Ganga. So keeping that in mind, we tried to assess the source rock characteristics of these potentially toxic elements. So to address the topic, we answer a few questions which sets the tone of why this project was, why we carried out this project. So the first thing is why these stream sediments are important. Now this work was carried out as part of the NGCM, or National Geochemical Mapping Project of GSI. And there we sample stream sediments from first order and at the most second order stream sediments. So, second order streams. So basically that reflects the geogenic values of those particular elements. So now stream sediments are natural archives of environmental change. So that is an important thing to note. And they reflect both current pollution as well as historical deposition. So we can monitor those changes through the analysis of stream sediment chemistry. Now, the importance of this particular monitoring is to monitor these trace metals, out of which we have selected 7 of them: cobalt, chromium, copper, nickel, lead, vanadium, and zinc. And these are elements which pose certain risks to human health and the ecological environment. Now, these PTs are, they can enter the food chain and they can get bioaccumulated they can bioaccumulate. So they can accumulate increasingly within higher and higher levels of the food chain. So with that, this was the basic concept, and we initially tried to predict certain baseline, not predict, but to calculate the baseline values of these PTs. But what we found was quite interesting, and that's what this presentation is about. So this is the study area. It is in the Vindhyan Basin, which is bordering the which lies in the bordering states of Uttar Pradesh and Madhya Pradesh. So basically the middle part of the geological map that you see, that marks the boundary between the two states basically. And the geology is represented by the Neoproterozoic to Mesoproterozoic sandstone and shale sequence of the Vindhyans. And if you see the land use land cover map, there is where the interesting points come in, that it's mostly occupied by agricultural lands and not much settlements, not much human inhabitations. So normally we would not expect any contamination from anthropogenic factors because there is not so much settlements there. But what we find and why we use GCM data to assess this is firstly because it provides a uniform national baseline. So there is a certain standard operating procedures and there are certain sampling intervals from which we sample these sample these stream sediments. Secondly, there is since we are sampling from the entire area, like it is represented in one of the in the false color maps map in the left side of the image. So it is an unbiased representation. So we did not only select potentially polluted polluted locations, but we sampled the entire area. So that provides an unbiased representation because we are not targeting certain certain samples. And then we use certain indices, contamination indices, which are basically calculations of whether these contaminations are due to anthropogenic activity or are natural geogenic background values. So with that as a background, these are our findings which I am going to enter into. So these are the data analytics. So the populations are mostly normally distributed. And if you see the correlation matrix, you will see the cobalt, copper, nickel, and vanadium, they are more or less strongly correlated. So, another thing that we did, which I will come to later on also, is we, to establish whether a source is contaminated or geogenic, we need to establish certain background values, right? So, for that background value, we took a reference element, which is aluminum Al2O3. And the correlation matrices show the good correlation between copper, cobalt, nickel, and vanadium. Now the significance of it comes later on. So to establish or to calculate these contamination indices, which will come later on in the later slides. So these are basically the geochemical, the geochemical spatial distribution, the geochemical distribution maps of the area. And if you see the reference values that we use, that is from Turekian and Wedepol 1961's shale values. So Turekian and Wedepol have established background values for all types of rocks, right from syenitic rocks and granitic rocks and volcanic rocks, all sorts of rocks. So we took the shale background because this is essentially a sedimentary terrain consisting of sandstone and shale. And if you see the values, they more or less closely reflect the natural geogenic values that are expected, except chromium and lead. And that is the important point to note here, that chromium and lead show more than expected values in the entire area. And these are some of the contamination indices that we calculated. The first is the enrichment factor. This is where the Al2O3 comes in, that it is a geochemical anchor basically to establish whether the values are natural. So any values that are well correlated with Al2O3 can be expected or can be interpreted to be geogenic in their origin. And if they're not that well correlated, then we can point towards some anthropogenic, we can doubt at least some anthropogenic activity is there. So the first is the enrichment factor. And if we see, again, other than chromium and lead, all of them are within the natural background. So there is not much, nothing to be alarmed of, but lead and chromium, they show some alarming signs. And to further establish whether this interpretation, because since enrichment factor alone is not enough to establish whether the entire population is affected by anthropogenic input at certain points, we also did geoaccumulation index of, or it's also known as Muller index. And this again compares present to pre-industrial background values. And again, we find except chromium and lead, all of them are within the safe or natural, or no, they show no pollution basically. But these lead and chromium, again repeatedly, if we see the previous one, enrichment factor, they show contamination, and these are marked by the blue dots. The minor sediment contamination is marked by the blue dots, and the severe contamination, which appears only once in the lead map, which is here, right? So other than that, all are so they are strongly affected, or this show natural geogenic behavior. So geoaccumulation index also again shows some contamination in terms of chromium and lead. And again, another index we used was the pollution index, which again shows chromium shows moderate or low levels of pollution in more than 80% of the samples. So, and again, similarly, lead continues to show its show signs of anthropogenic input, which is quite surprising considering the fact that the area is not much expected to be contaminated by anthropogenic factors. So, and we also used a few other contamination indices, some of them being the contamination degree of Håkansson, the modified contamination degree, both of which show natural values. So we did not plot maps separately for that because they are well within the accepted ranges. However, the pollution load index, in terms of that, chromium and lead again shows some moderate pollution due to human-induced activity or anthropogenic activity. And there is another factor that we used. Now this directly addresses the ecological risk that is associated with these contaminations, that is the ecological risk factor. So what it does is it considers the toxicity of these separate metals separately. So you can see these values, lead is 5, copper is 5. So in terms of the damage they can cause to the biota, they have been assigned certain factors. And the good news is that in terms of that, in spite of the geogenic, the anthropogenic inputs or the apparent anthropogenic inputs to the data set, fortunately these ecological risk factor and potential ecological risk index, which is again a sum of all the contamination factors taken together, so summation of ER or ecological risk, these don't show much signatures of alarm, so they show low. They are mostly fall in the low category. So it's not. It's still till now. It is at least our data set shows that they do not pose a tremendous ecological danger as such. But the point to note is that there is at least some anthropogenic input to lead and chromium. Now these could be anything from burning of fossil fuels to road dust accumulated due to the passing of a highway close by. It could be due to disposal of, say, lead batteries and such sources. So it could be a multiple number of sources. Now our work here is not to identify exactly what those sources are, but to point out that there are some sources of potential danger in these parts. So, and finally, what we did to simplify the complex data set, we used principal component analysis from these group of 7 potentially toxic elements. And obviously the PC1 or the principal component 1, it represents the geogenic behavior. And it, if we see that carefully, the aluminum, the Al2O3 is well correlated with the cobalt, copper, nickel, and vanadium. So they show clustering, which means that the behavior of these are geogenic by nature. Now zinc, although it shows, zinc is slightly surprising in the fact that zinc shows a separate trend, like in this, like shown in this plot. It shows separate behavior, but none of the indices we used show any contamination of zinc. So it has a completely independent behavior, which which is probably related to geogenic factors itself. And finally, the PC3, or the principal component 3, it shows a strong loading of lead. So in terms of playing around with the data, in terms of the different contamination indices, as well as the principal component analysis, we repeatedly see that lead and chromium are, there is some potential danger of lead and chromium accumulation.
Please try to conclude.
Okay. So lead and chromium show some potential of anthropogenic inputs. So that is an alarming sign. And this was our purpose for a safer tomorrow, as the topic is, for a safer tomorrow, to use NGCM data, which is a benchmark project of GSI for the last 20 years or so. So finally, I'll conclude, and the future directions also. So our conclusion is that most of our samples are dominated by natural geogenic controls. There is some localized lead enrichment and some chromium also. But fortunately, there is still low ecological risk overall, and it establishes a robust baseline from the NGCM data. And the future directions for this study is the long-term monitoring of this lead and chromium, and also the source fingerprinting, which will be helped by lead isotopic studies to establish what kind of anthropogenic sources these could be originated from. And we also need integrated ecosystem assessment to further combine our studies with soil samples and agricultural runoff, etc. And finally, we need to extend our geochemical mapping to study such environmental concerns, so that we can contribute to the future decision making and policy making for a greener India. So with that, I will conclude. So thank you very much for your patient hearing. And now, if you have any questions.
Any question?
Very good presentation. Thank you. And I want to ask, what about the cadmium and mercury?
Yes, they could definitely be considered. For this particular study, we selected these 7 elements. You could do it with a few other elements as well, like arsenic, cadmium, mercury. All these could be used. For this, we have not, because if we had found contamination in that also, that would be a completely different.
That is because a small amount of cadmium or mercury,
absolutely,
the loading factor is the contaminating factor is quite high, probably around 30 or 25.
Yes, the toxicity index of arsenic is, I think, 10.
For cadmium and mercury, it is quite high range.
Yes,
so that way, the truth may be hidden there, because if those elements are considered, the PERI or those indices you have calculated, that might go on the higher side.
Absolutely, it could go on the higher side.
Yes.
But our purpose is to point out that we could, actually we started this project just to establish the baseline values. But when we played with the data, we saw that we were finding actually contaminations, which was not expected in such a terrain. So, and definitely your opinion is right. We could use a lot of heavy, because potentially toxic elements includes other elements, other metals like arsenic, cadmium, mercury, all these. So it could definitely be used. We haven't used it for this particular study, but we do have that in mind, that we'll for further research we'll actually include.
Okay, Shyam, okay. Any questions?
Thank you.
Yes, sir. Yes, sir.
For example, shale, of chromium, all the elements.
Right, sir.
But suppose, I mean, there can be some natural anomaly, anthropogenic. Why they have to be anthropogenic per se? I mean, suppose you are getting an anomaly, but that anomaly can be even natural.
See, it could be natural, but sir, that is why we carried out these contamination indices, which always take into consideration the ratios. So, for example, it will for the enrichment factor, for example, it takes into consideration the Al2O3 and the contaminant ratio. So if that is maintained overall, then it won't show any contamination. So just like, for example, in the principal component analysis, although the zinc is showing a completely different character, but we are not connecting that with any anthropogenic factor, because it is showing completely different behavior, and it is in the contamination indices.
Natural. It's natural.
Right. So
But your chromium and lead.
Yes, sir.
These two, you according to your findings, you are telling perhaps there is an anthropogenic contribution.
Yes, sir.
But I mean, based on those ratios.
Based on those ratios and the
so there is
principal component.
not that possibility, because of the ratios you are telling there is no possibility of perhaps a natural contamination.
It's unlikely, sir, because the Turakian and Wedopol's values for all the shale values are more or less well defined. So within closed limits, it won't show any contamination. But if you see the background values, like in this slide, for lead, you see it's more than double that. So even just the background values.
For example, if there is a sulfide deposit nearby.
Yes.
And that is contributing to it. Whether there is, I mean, the ratios will remain the normal shale value.
So then it will show some local contamination. It could show some local enrichment. But as far as this particular is concerned, we are finding it quite consistently throughout the area. So now we don't know the exact factors that are responsible for this particular contamination, but basically our main purpose is to extend the ambit of NGCM data, that we have such a large amount of data and we can really use that data to good use for a greener India or environmental sustainability. Absolutely, sir. Yes, sir.
Sam, there is a very small question. Rather, there is a query that you have collected the samples, whether you are representing the results of the composite samples here or the unit cells also?
No, the composite samples.
Only. This is the presentation of the composite
samples.
And
yes,
whether you have demarcated exactly the river basin or it is the presentation on a topo sheet scale?
It's a topo sheet scale. From a particular topo sheet, we have taken the entire data set and we have played around with that data.
Mark,
to tell you
yes,
that you have deduced some empirical parameters only.
Yes, sir.
But try to understand the genetic reasons behind it. In your work, you have to explain that why these geogenic things are coming. Okay.
Right, sir.
No need to answer this. You think about it.
It's sparsely populated, yes.
Next speaker, please come
We
up.
have to find out what could be the reason for this. It indicates it can be a geogenic reason for
Absolutely,
this contamination, because anthropogenic activity is not much in that area.
Right. So that is why, sir, some isotopic studies are needed to characterize that, whether they are anthropogenic or naturally occurring. So we need further studies for that. Thank you.
So good evening to all the dignitaries present here and the officers. So today's my topic is a comparative study of landslide susceptibility mapping using bivariate statistical and machine learning methods in the Upper Bhagirathi Valley, Uttarakhand, India. So as we all know, the Himalayas has been a hotspot of natural hazards. The Yangpol Mountains of Himalayas are geodynamically active, and therefore they are highly vulnerable to the hazards due to its complex geology, dynamic geomorphology and hydrometeorological conditions. So the state of Uttarakhand is highly prone to the landslides, and till now we have marked around more than 16,000 landslides, and also based on process we have tried to distribute it, like there's about 37% of landslides are debris slides and 63% are the rock slides. Also, we have further tried to differentiate in the form of rockfall, rock slides. And there are also some few unclassified data that we have found from the Google Earth imagery, for which a field check is required. Then my study area here is concentrated to the upper parts of the Bhagirathi Valley, starting from the Chinyalisore to Uttarkashi and covering till Gangotri area. It is a part of Char Dham Yatra route, and it is a very important pilgrimage spot along with its strategic importance, covering the bordering parts of India. So the region has experienced an increase in frequency as well as the magnitude of landslides in the recent past, as we have seen possibly in the last year, due to enhanced anthropogenic intervention, rainfall, erratic rainfall pattern, and development of new road cuts. It's a construction of bridges, tunnels, etc. So the study area mainly lies in the parts of inner resident Himalayas and higher Himalayas. Then there are several landslides, very important landslides, as Sir has also shown in this presentation, that Varnavrat landslides, Nitala, Siror, Jhala, Gorsali, Gangotri, many important landslides occur on this road sector. So it is an important area of study. And recently, the Dharali and Harshil incidences. Next, firstly, in order to demarcate, my topic is to demarcate the occurrence of landslide, that is the landslide susceptibility mapping. So firstly, we need to understand that what are the factors which are responsible for the occurrence. So this area is structurally traversed by several thrusts, such as MCT is passing through this area, then Vikrita thrust is passing, then several shear zones have been demarcated, then there's differences in the competency contrast of lithology. Then in this, the rocks are highly jointed with 3 to 4 sets of joint, leading to planar wedge failure giving rise. And then the Bhagirathi River, since it is flowing, it flows in a form of V-shaped constricted valley and a very steep gradient, so it can lead to toe erosion. Then there is also freezing and thawing action at the area, my study area. It lies, has an elevation of from 1,000 meter above sea level up to 5,000 meter above sea level. Then the methodology in my topic that I have adopted is, so firstly, I've tried to find the then derivative maps and collection of land, followed by the satellite imagery data. Then tried to find the analog data, so geomorphology, lithology, rainfall, then distance to the linear features such as thrust. Then a proper landslide inventory has been prepared in the form of landslide polygons, and also the thing I've done is I have also prepared the polygons for the non-landslides areas. So we are trying to find the susceptibility in the form of 5 methods. First is the bivariate statistical method, then we have utilized the machine learning methods of 4 types of machine learning methods, and we'll probably be finding that which of these methods will be the most accurate in our study area. So random forest, K nearest neighbor, XGBoost, and naive Bayes I have tried to use. Here we have tried to separate the data in the form of polygons in the form of training data as well as the validation data. 70% of my data has been used as a training data, and 30% has been utilized in order to validate these maps. Followed by this, the model training is done by applying different algorithms for each of the machine learning tools, and also bivariate statistical method, that is a probabilistic GIS-based approach we have tried to use. Then how to validate these models? We have tried to use the sensitivity analysis, confusion matrices, and then followed by this, we have tried to plot the receiver operating curves, sensitivity against specificity, then overall accuracy and the precision. So firstly, these are the thematic maps that have been utilized in my model. The linear feature, distance to road, distance to thrust, then lithology, then LULC, landslide incidences have been demarcated in the form of polygons. Then we have the DEM derivative maps. We have used the spatial DEM derivative maps using the CARTO-DEM data of 9.5 meter spatial resolution. In this, we have generated the topographic wetness index, stream power index, then elevation, slope, aspect. So these 12 thematic maps I'll be utilizing in order to generate our susceptibility maps. So firstly, understand what are these models. The first bivariate statistical model is the weight of evidence. In this, it is a probabilistic GIS-based approach in which we assess the susceptibility by analyzing the spatial relationship of the past landslide which has occurred. So the important assumption that I have made in this model is the landslides occurring in the past will be the determining factors that this landslides in the future will occur under a similar set of condition. So weight of evidence calculate the positive and negative weights for each of the factor classes, and we generate a posterior probability maps. So some of the limitations that I have found can be said about the weight of evidence method is that it can assumes that all the factors are conditionally independent among each other. Then let's come to the machine learning part. So there are 4 models. Then firstly, we'll understand what is the naive-Bayes method. Or the KNN is a supervised machine learning algorithm. Here K is understand for the number of neighbors or the nearest neighbors. It is non-parametric and instant-based algorithm. It is calculated using the Euclidean distance between the data points. Suppose it is, we are calculating in the form of pixels. Each of the pixel is of resolution 9.5 meter we are considering. So all the neighboring characters are generated within the data points. Then this is the model that we are using for the K nearest neighbor. Then we have the different other models that we are utilizing. Then the naive Bayes. That is the classification algorithm which is based on Bayes' theorem. It calculates the conditional probabilities. Here the naive means that the factors are conditionally independent of each other. Then NV classifier, it also demonstrates that the data is resilient to noise and it removes the irrelevant attributes. Then the next is the random forest. Random forest, it is an ensemble-based bagging method. So it builds individual trees. A number of individual trees are built during decision making. Both classified and regression tasks it can able to do. Then in the training phase, the algorithm partitions the data sets, and these trees produce diverse predictions. So here a voting mechanism is applied. So the final prediction is the highest ranked result among the voted outcomes. It is robust to noisy data and can handle very huge or large number of data sets. Then finally the extreme gradient boost, that is the XG boost. It employs a regular boosting technique. It focuses on reducing the error. That is, it focuses on hyper-tuning the factors. The algorithms by assigning weights to the misclassified attributes. The data is trained repeatedly till the error is minimized. Here we have what the most advantage is. We can reduce the error in the form of hyper-tuning or training our data sets. So then the models are validated. So validation technique is what we use is here, ROC curve, sensitivity and specificity. So these are the susceptibility maps that have been prepared. Firstly, the weight of evidence method. Here, after the validating this susceptibility map, where we see that from the ROC curve, that about 72.25% it is showing the accuracy rate. Whereas these are the other 4 maps which are showing different specificity rates, such as random forest is showing 88% accuracy, naive Bayes is showing 87%, KNN is showing 82%, whereas the extreme gradient boost is showing a 91% of accuracy rate. Here the accuracy rate, let's understand how we are calculating. So this is the area under curve or the ROC curve. This is the receiver operating characteristic curve. Here we are seeing that we are trying to correlate as we have firstly prepared a landslide inventory and then prepared the raster maps. On the basis of inventory, we have tried to prepare the susceptibility map. In the susceptibility map, we have not tried to, we have generated landslide and non-landslide polygons, and a comparison is done. So based on this, we have tried to generate the specificity against sensitivity, leading to plotting of the ROC curves. Then we have also tried to generate the confusion matrix. So confusion matrix is, it is a tabulated form here with the true positives and true negatives, false positive and false negative. These 4 types of pixels are calculated. So if it is true positive and true negative, whichever, if it is highest, then our model is accurate. Here, after comparison or the validation of all 4 models, it was found that the extreme gradient boost is showing highest accuracy among all. Then a pairwise plot of the hyperparameters in order to boost the accuracy has also been plotted here. That is also conforming with the XGBoost model. So here, let's understand what is the comparison or the comparative study. So machine learning methods are able to handle very large number of data sets as we are, as year by year we are generating more and more data sets, and whenever we are using GIS tools, it leads to like our systems are hanging and we are not able to process. So this technique will be better if we utilize it with increasing number of landslides these days. Whereas traditional methods are limited to a complex data set, but it can be limited to a very small area. Then it can capture non-linear relationships, whereas traditional methods are mostly related to linear relationships, because we are not able to train the data sets. We are able to train the data set only one single time. Then the parameter weighing, it has an automated factor importance. Accuracy, as I have seen in my model, which the area in which I have done, it is generally showing a higher accuracy. And one thing more I would like to include here, that the models that we are utilizing, I'm saying that the extreme gradient boost is showing the highest accuracy, but it is very much area specific and the data that we are utilizing. So still we have to do a lot more research on which model will be the best. For my area, this is what is working. It is not specific that it will work for other areas as well. So then generalization, it has a good transferability. Then it has a higher computation machine learning methods as compared to traditional methods. Then it is highly automated method, so it is faster and very robust. Then amongst these methods, based on my preparation of susceptibility maps I have done, so what is the comparison? So KNN, that is the K nearest neighbor, is showing a very noisy production, and the heterogeneous surfaces are shown because it can be sensitive to the irrelevant data. Hence, because it is only considering the data which is nearer or in the neighboring parts. Then the naive Bayes, it can be sensitive to the outliers. Here it is not removing the outlier data. Then the random forest, it has a tendency to overfit the data since by generating of the decision trees, and it works on a fixed set of parameters. Though the advantage that we are getting in our extreme gradient boost model is that it can adjust the parameters by hypertuning iteratively or repeatedly. Then it is highly robust when any slight changes in any of the conditioning factors. So as I mentioned, I have used like 12 thematic maps. If we increase or change these maps, so my model will show changes. Next, so here from this very preliminary study, I would say, I can say from the analysis that from these machine learning model that XGBoost is showing a highest accuracy and has outperformed the other remaining 3 models. So, and the landslide susceptibility map prepared using this model is showing a 44% that of my area lies in the high susceptibility zone. Then the high risk areas can be designated as non-residential, and low impact land uses can be done for exposure of vulnerable populations. And monitoring of the high risk zones can be done. Authorities can trigger timely alerts since it is a faster mode of generating susceptibility maps on a day-to-day basis as we are generating more and more data. And the limitations, what I would say in my model, which I found, is that I have not considered any earthquake data. I have not considered the avalanches or the snowfall data, since the freeze and thaw phenomena which is happening in the higher Himalayas is also one of the causes that can lead to generation of or degeneration of the rocks. Then way forward is that we can generate risk and hazard maps as we collect more and more order temporal variabilities of this data. Then thank you, and this is the Dharari landslide as sir has mentioned. This was the photograph which was taken by me during my field work. The right side of the photograph during the month of January, and this is the photograph which I got after 5th of August. My camp was located on this fan. I lived there for 3 months, and it is no more, and it has been a very sad moment for me. I was able to lose a lot of people because of this landslides. Thank you.
Good presentation. Thank you. Any question?
Yes.
Thank you for the presentation, madam. एक चीज़ like like you have said, no, you have taken consideration of the landslide inventory. So in that case, first of all, I would like to know for how many years, like what is the duration of
My
the
inventory database was from year 2022 to 2025. I worked along the 120-kilometer stretch of the Char Dham Yatra route.
Okay.
So these are the polygons which I generated the inventory, and I have used that data.
So only the polygon methods are you are using?
Yeah,
for
we
this
can
modeling?
utilize the point-based method also and the polygon also. For a better, for better accuracy, I've tried to use the polygon data because since I've done the field work, point data is generally used if we are using like spatial data or using Google Earth imagery when we do not know that how much far the landslide is going.
Yes.
Since I have already validated all these landslides, so I have tried to utilize the polygons.
Okay, ma'am. Now the thing is that like traditionally as per what we have, the standard procedures we are doing. Now we have generated some data and we are all looking forward to add in the AI ML techniques into this by ourselves. Now the thing is that in ML, like if we try to make the susceptibility maps, like what I am reading is that suppose in my area, if my landslides are concentrated, or else I would say it like that, if I'm if I'm getting my landslides in some specific or restricted areas, then will that affect my model? For example, if my suppose I am taking or picking up the data of a specific topo sheet. In that topo sheet, hardly 2 roads are crossing. It's a remote area. In that case, what is going to happen is that mostly the landslides are concentrated or biased
Along the road.
along the road structure.
Because of the
or
anthropogenic activities.
Yes. First of all, they are naturally concentrated, as well as during inventory also people are getting those data like more accurately,
Yes.
which is near to the road sectors. So when I am taking those data for my validation, will it pose any kind of issue in ML? Or
so it won't pose
will
any kind of
ignore
issue
it?
since I have also considered those linear features. As you have said, there are only 2 roads passing. So firstly, I have taken in my thematic map the linear feature, that is distance to road. That is been considered. That is an important factor which is contributing towards the occurrence of landslides. So I don't think those polygons along the road, if you are taking, that is going to affect. So as much as your if you are feeding or the thematic maps or your models in your data, you can change that as per your requirement.
So in that case also ROC is applicable, right? Like even if the data is concentrated, in some restricted areas, still we can use the ROC for validation for ML also.
Yes, that can be utilized.
Okay, thank you.
I think we have another presentation, so I thank you, ma'am.
Thank
That's
you,
good.
sir.
I will talk to you later. You are Mr. Binu Kumar? Yes, please. Already, please.
Good evening, everyone. My topic of presentation is rock mass characterization and soil modeling for 200-meter depth zone in Ganat Yadgir district, Karnataka. Basically, is a layout of the presentation will introduction, host stroke, general geology of the site, 3D geological RTQ modeling, numerical modeling, results discussion, conclusion and references. First of all, why we need this work? Basically, India is one of the major country in which the nuclear power is one of the major resource for our energy mix in Indian program. For the Amrit Kal vision also, we are targeting for 100 gigawatt of the energy from the nuclear resource. For that, we require lot of nuclear reactors. From the mining, the fuel is fabricated. In the nuclear reactor, the energy is generated, and then after the waste are generated, that from the reprocessing, lot of wealth of the radionuclides are generated that are required for the cancer and other treatments. Then after the waste is immobilized in the waste management plants, that is further stored for the 100 years of a time. Then after the waste is stored in the underground repository, basically a combination of the shaft, tunnels, all the things, in which it will kept for the more than 10,000 of the life of the years, so that the its harmful effects can be isolated from our ecosystem. So for this, we required this type of disposal system. So for this, we have selected as a granite as one of the good candidature, and worldwide also the granite is one of the prominent source for this work. In India, more than 20% of the is covered by the granite and distributed all over India. So it is a beautiful that we can select anywhere in India. Second, there are a lot of areas which are in the low seismic zone. That is one of the most criteria for the selection of the site also. So for this, for the Yadgir district, we have carried out the 3D geological modeling coupled with the wedge and stress modeling, and then after the tunnel was also excavated, and that was verified by the actual conditions also. So this is the local geology of the site. Basically, in this, it is a Bhima Basin area, and at the depth of 200 meters, there is a granite, and total more than 56 rock core samples has been also mechanically characterized for getting the UCS tensile, its hardness and other properties for the modeling purpose also. And one fault also exists there. So in this 100 meter by 200 meter of the area, up to the 350 meter of the depth, 5 cores has been, bore holes has been drilled, and at the corner 4, based on the 4 boreholes, the mapping was done, and that was validated with the one validation code that's been done. And this is the typical from the 200 to 210 meter depth. RQD value is also mentioned here. It's a good quality, and also the various parameters like UCS, Young modulus, internal friction angle, joint friction, stiffness and shear modulus, all parameters has been investigated for this zone. Then after in the first, the RQD modeling has been carried out in the RockSolid software, and more than 44,000 of the nodes have been generated, and this the map was generated, and it was seen that at the 200 to 200 depth and the 270 to 300 meter depth, zone is there that is good for the tunneling purpose. Yeah. So it is showing the results of that part. Then after this validation, wedge analysis has been carried out, and all like western direction, north, south, and north south direction, all that has been analyzed, and it is found that in the western direction there is a least probability of the wedge formation, and that was selected. Now after this, a numerical analysis has been carried out based on the finite discrete element analysis that couples with the fracture modeling, and having the 4-noded element and the 3-noded triangular element for the crack modeling. And this is the total domain has been selected of 3 meter by 4 meter of the excavation is carried out with the total boundary of the 20 meter by 20 meter, and the site is existing prevailing fractures in the vertical and the 45° of the angle has been also modeled to carry out the realistic modeling. And this is the input parameter. This is the joint has been also modeled, and this is the actual excavation carried out, and in the roof has been shown here. And these are the input parameters for the intact granite rod with for the Hugh-Brown model. And this is the joint stiffness, joint normal cohesion, internal flexion. Initial aperture is also measured, and that is also taken account in during the modeling purpose. So it gives the realistic picture. So this is the excavation has been covered. It is seen that the corner, the localized stress is there. In the top roof is also some wedge formation is also is seen there. So basically these are the so only the bolting can sufficient for this type of the support structure. So in the conclusion, it is seen that the systematic approach has been done. The RQD 3D modeling has been carried out. Based on that, the site selection has been carried out. Then after the in mechanical properties has been investigation for that site, and then after the wedge and the finite discrete element based analysis has been carried out to see any support requirement or is required or not, and then after the thing has been actual validated by excavation of that 3 meter by 4 meter of the rectangular shaft in that rectangular tunnel in that. Yeah. These are some references for this. Thank you for listening. Yeah.
Question. If any question is not there, let me ask you one question. What is the depth of this chamber from the surface?
200 meter.
200 meter. How many boreholes you have done for the initial investigation?
Actually, in the 100 meter by 200 meter of the area, we have drilled 4 corner boreholes at the depth of the 350 meter, and then after the based on this all the parameters, the 3D modeling of all the things has been done. And the 5th borehole is also made. That introduced to all them, and then after it was seen that it's valid. No doubt, more boreholes there.
So,
but
do you do any borehole breakout test also in these boreholes for the stress measurement?
At that time it was carried out, but that results are not seen here.
Okay. Thank you.
Yeah. Thank
Good.
You. No. In the tensile instance, basically we have carried out the Brazilian test. Based on that, we have values has been taken, because basically in the finite discrete element methodology, we have to model the fracture. In the fracture modeling, UCS is quite not enough to model the fracture. We require the tensile strength and KIC mode 1 fracture parameter also. Basically, that is to model the fracture, how much of fracture energy is required to crack at that time. So all parameters has been given to this finite element modeling.
Because why I was asking, because 6.3 GPa is your Young's modulus.
Yeah.
And their corresponding tensile strength is, I think, more than 1 MPa.
It should be 10 times. I will. It may be.
Just next table.
Okay.
Yes, this one. Tangential stiffness.
Yeah, this is the parameter of the joint stiff. It's a crack.
But it is really isn't it a little higher side?
Yeah, it is basically it is not an intact rock property. It is basically the when the two blocks of the joints slips at that time.
That I understand.
Yeah. So that's why some variation is there, because it is not an actual intact rock tensile property.
Because see, cohesion of 1 MPa, that also shows quite compact mass.
Yes.
Compact joint, and for that this normal stiffness.
But you can see that aperture is also 68 micrometer. So there are a lot of heterogeneity in the things.
Again, Poisson's ratio is quite low, 0.15.
That Poisson ratio is different. Poisson ratio is basically for intact. Basically, in this modeling, in the conventional modeling, what we do that we give the UCS modeling intact rock mass property, and then we assume that after this strength index is this much, so wedge is formed or spelling will be there or burst will be there. But in this modeling, what we have done is basically the exact joint property we have given. Basically, in this we have modeled the rock mass with inbuilt crack feature. The crack will be open or closed only when the values of this KIC, that mode 1 fracture, basically that dominates for the beta characteristics, that exceeds the energy required for the crack propagation. And for this, that's why these two properties are entirely different. Basically, the right side one is showing the properties for the joints. That is basically a calibrated property taken from the literature, and some property from the our own experimentation.
Yes,
but left side values is purely
lab
experimented.
Lab value, na?
Yeah, left side value is purely lab value.
Lab test.
Lab test.
Not in situ. Okay.
Yeah. Yeah, that is required. That is our in the next stage. That basically it's one of the preliminary study.
Basic idea.
Yeah.
Yes, yes.
It's give the methodology that we should follow like a step 1, step 2, and step 3, and then after we have to realistic. So it will avoid any disasters or anything during the excavation, all the process. And also in this in this rock mass, in the conventional modeling of the tunnel, we avoid, we don't take the excavation damage zone property. Here we have taken, as per the actual what we have found there.
Because you have done 4 drill holes on all the corners of the powerhouse.
100 meter by 200
This was
meter.
a fit case for using the Goodman jack.
That will be in the next step it will done.
Thank you. Thank you, Binuji. बहुत अच्छा presentation. I am very happy to see this. ठीक है, good. Thank you. And I now request, I think all the presentation is over. So I request my co-chair to say a few words.
Thank you, sir. First of all, I would like to thank you for giving me an opportunity to be present here in this august presence of all the dignitaries and persons and geoscientists from abroad also. Thank you. And as the tone was set up in the morning in the plenary session by the lecture and the presentation delivered by Fasto regarding landslides, so we carried out the theme, and it is very pertinent in the present times, geohazards decoded. And in this endeavor and to drive deep, our National Mission Head of Geological Survey of India, Dr. Saibal Ghosh Saab, has given a very detailed account of the landslide occurrences in the country, their distribution, their mitigation measures, and the way forward, how we should move ahead. As he is our leader and he leads the Mission 4, he has given all the insight of the activities that GSI is taken in the field of landslide mitigation and studies. Furthering, I would like to now request sir to say a few words.
No, this session is short, small, but we have a varied presentations from different topics. One is on the contamination. This is a very interesting presentations. Only thing is that I think the speaker, the author will now try to explain the geogenic causes, why it has happened. He has deduced some empirical parameters through which he can at least tell that there are strong examples of or evidences of geogenic these things. And second presentations after that, the madam has given a very good presentations. Today is the world of AI ML, so she has given how the accuracy is increasing as you go. But I think there are a lot of things we have to tell because the accuracy is not only the sole thing for landslide susceptibility mapping alone. We have to also give importance to the predictor variables which we are using. Set aside the explanatory variable, but the predictor variable mapping and the collection of that data has to be very, very perfect. Today morning I was listening one plenary lecture of Professor Izem Karanza. He is a very famous man for mineral prospectivity mapping. He was also telling that all the conventional method has a problem that if I garbage in and garbage, then the garbage will be out. So as we improve upon our modeling capabilities, we have to give also more importance about the uncertainty analysis about our map, the predictor map, also the explanatory variable map. Everything we have to give importance. And also another thing, madam, perhaps I think he could not do because he had a very short span of data. it would be better if we take a time span of data and use it for training data set, and then another time span of data for the testing data sets. Then it becomes more fruitful for the prediction purposes, because the map we are preparing, we are predicting for the future. So that is another thing. And this presentation, the last presentations by, this is a very new area where the entire government of India is investing huge amount of money, and GSI is also involving in this investigation at a certain stage. I am very happy to see that how the site-specific suitability is being attempted in a very concerted manner. Thank you to all speakers and the audience for giving a patience hearing to all the speakers. Thank you very much.
Thank you to our respected chair, co-chair, and all the speakers for your valuable contribution. May I now invite Shri Sheeladitya Sengupta Sir, DDG PSS, PNM, GSI, to kindly felicitate our session chair, Dr. Saibal Ghosh, and our co-chair, Shri Manish Khar, with memento as a gesture of our sincere appreciation for their guidance and support in this session. With this, technical session 2 concludes. Thank you to all the participants, speakers, and delegates for making today's session special. In some time, our cultural program will start. You are now invited for the same. Thank you.